Welcome back. Hey, my dear friends. 12,000 years ago, the world began to melt. Ice sheets taller than mountains fractured and crumbled. Seas climbed over ancient hunting grounds. Mammoths faded from the open plains. Forests swallowed old landscapes. And human beings standing at the edge of a dying ice age had to make a choice. Move, adapt, or vanish. This was not simply the end of the cold. It was the birth of the world we know today. Before we go further, take a moment to hit like and subscribe if you enjoy this kind of history, mystery, and ancient Earth storytelling. Because when the Ice Age finally ended, it left behind more than silence. It left drowned lands, vanished giants, forgotten peoples, and the first fragile steps toward civilization. The ground is not quiet. Beneath an iron-colored sky, the world groans under ice. Far north, frozen water rises like buried continents, crushing valleys, grinding mountains, locking entire regions beneath a silence so heavy it feels eternal. The seas sit lower than today, pulled down by the immense weight of water trapped on land. Coastlines reach far past their modern edges. Islands are hills, shallow seas are plains. Rivers carve through landscapes destined to vanish beneath waves, leaving only sandbanks, fishing grounds, and strange bones dragged up in nets, clues to a drowned world. This is the world near the end of the last ice age, not dead, but tense with life. Mammoths move across open steppe, their dark hair stiff with frost. Reindeer follow seasonal trails across wind-scoured ground. Horses, bison, woolly rhinos, lions, wolves, and humans share a landscape built on cold, distance, and risk. This is no simple wilderness. It is a living system with rules. The people who survive here know those rules with a precision no written map could match. They read snow, dung, tracks, wind direction, stone, bone, fat, smoke, and silence. They know when herds pass as the season turns. They know which valleys offer shelter, which rivers can be crossed, which raw materials make the sharpest blades, which animals turn dangerous when hungry, and which storms mean death if shelter isn't found quickly. Before we go deeper, take a moment to like and subscribe if this is the kind of history and mystery you enjoy. Because the story of what happens around 12,000 years ago isn't just about ice melting. It's about an entire planet changing its mind. To truly picture this world, forget the familiar map. Europe is not Europe as we see it. Britain isn't yet an island in the same way. A broad lowland stretches where the southern North Sea lies today. A cold, fertile plain of rivers, marshes, lakes, and herds across the far northeast of Asia and northwest of North America. Beringia isn't a narrow strait, but a vast land bridge, a harsh yet habitable world linking continents. The Persian Gulf is partly dry land. The Sunda Shelf joins many Southeast Asian islands into a larger landmass. The Adriatic reaches less far inland. Everywhere, shorelines are misplaced. The planet's edges are not where modern eyes expect them. Humans live within these altered geographies, but not as helpless wanderers trudging through disaster. By this time, Homo sapiens has spread widely across Africa, Eurasia, Australia, and the Americas, though the details of those movements remain incomplete and sometimes hotly debated. People have already survived volcanic winters, glacial advances, droughts, unfamiliar animals, and encounters with other human forms now gone. Neanderthals disappeared thousands of years earlier, leaving traces in the genes of many living people. Denisovans are known mostly from fragments of bone and DNA, their full story still hidden in the record. Modern humans remain, but survival has never meant comfort. It means flexibility. It means memory. It means passing on the exact knowledge that keeps a group alive when the weather turns against them. Around 12,000 years ago, the world stands near a threshold. The great cold is weakening, though not smoothly. The climate doesn't change like a door gently opening. It lurches, pauses, reverses, accelerates. A person born into one generation may grow up hearing stories from elders about animals that no longer pass through the same valleys, snow that used to last longer, rivers that have shifted, lakes that have swollen, coastlines that seem to creep inward year by year. These changes are slow by the measure of a single day, but fast enough to matter across a lifetime. The land that taught people how to survive begins revising its own lessons. What survives in the record suggests a world of both opportunity and danger. Warming can create new plant growth, open new routes, lengthen seasons, and bring forests into places once ruled by grass and tundra. But warming can also destroy a way of life built around open country herds. It can turn firm ground into marsh, familiar hunting grounds into woodland, and coastal camps into future seabeds. Melting ice can feed rivers until they rage. It can form giant lakes, held back by unstable walls of ice and sediment. It can release floods so large that landscapes are rearranged in days or weeks. The evidence remains incomplete, especially where the sea has swallowed old coastlines. But the pattern is clear enough. The end of the Ice Age is not one event. It's a chain reaction. The ice sheets themselves are almost impossible to picture at full scale. In North America, the Laurentide ice sheet spreads across much of Canada and reaches into what is now the northern United States. In Europe, ice covers large parts of Scandinavia, Britain, Ireland, and northern lands beyond. These are not simple white blankets. They are moving masses with internal rivers, crevasses, pressure ridges, and edges that carve, collapse, and grind. They lock away enough water to lower global sea levels by more than 100 meters at the glacial maximum. They shape winds, reflect sunlight, redirect storm tracks, and press the crust of the earth downward under their weight. When they begin to retreat, the earth beneath them slowly rebounds, as if the planet itself is inhaling after being crushed. For the humans living south of these frozen walls, the ice isn't always visible, but its influence is everywhere. The cold helps maintain the Mammoth steppe, one of the strangest and most productive ecosystems of the Ice Age. This is not a uniform wasteland. It is a broad, dry, grassy world, stretching across huge parts of northern Eurasia and into Beringia, supporting animals of enormous size and number. The name can mislead, because the Mammoth steppe isn't just about mammoths. It's a mosaic of grasses, herbs, sedges, low shrubs, exposed soils, and seasonal abundance. It exists because of conditions difficult to reproduce today: cold, dryness, wind, grazing pressure, and nutrient cycling from large animals. No single explanation fully accounts for its richness, and scholars still debate exactly how all its parts work together. In places, people mark this world with astonishing skill. They carve animals into bone and ivory. They paint caves with bison, horses, lions, rhinos, mammoths, signs, dots, and forms whose meanings remain uncertain. They make tailored clothing from hides and sinew, build shelters from wood, bone, hide, and earth, and carry symbolic objects across long distances. Stone tools are not crude leftovers from a primitive age. They are precise technologies produced through learned sequences of blows, pressure, heat treatment, and selection of raw material. A blade can be a hunting tool, a butchering edge, a woodworking implement, or a small part of a larger composite weapon. Bone needles, spear throwers, fish hooks, nets, traps, grinding stones, pigments, beads, and burial practices all remind us that Ice Age humans are not waiting for civilization to begin. They are already fully human, with grief, planning, beauty, status, memory, and danger woven into their lives. Yet the stability of this world is deceptive. From a distance, the Ice Age can look like a long, frozen era, but it is full of pulses. Cold phases deepen, warm intervals open, glaciers advance and retreat, sea levels fall and rise, ecosystems migrate, human groups move, split, merge, vanish, and return in ways archaeology can only partly reconstruct. By 12,000 years ago, much has already changed from the peak of glaciation. The planet is warmer than it was at the last glacial maximum. Ice has begun to retreat in many regions. Some animals are under pressure. New habitats are appearing. But the final passage into the Holocene, the warm interval in which all recorded history will unfold, is not yet complete. This is what makes the moment so powerful. It is not the beginning of humanity, but it is the beginning of the world that will make later human history possible. The landscapes of empires, farms, ports, roads, cities, temples, and written kingdoms are being prepared by meltwater, vegetation, erosion, and rising seas, but no one alive at the time sees it that way. There is no grand announcement that the Pleistocene is ending. There is only the changing behavior of animals, the loss of old roots, the spread of unfamiliar plants, the arrival of new wetlands, the retreat of snow, the deepening of rivers, the drowning of lands, and the pressure to adapt again. The mystery, then, is not simply why the Ice Age ended. Scientists can trace many of the broad drivers: shifts in Earth's orbit, changes in sunlight distribution, greenhouse gases, ocean circulation, ice albedo feedbacks, and complex interactions between atmosphere, ocean, and land. The deeper human mystery is what it meant to live through the ending. What did it feel like when a world that had lasted beyond memory began to dissolve? How many stories were lost when the coastlines went under? How many hunting grounds, camps, graves, ritual places, and paths now lie beneath continental shelves? How much of the great transformation is invisible because the evidence is drowned, decayed, scattered, or never preserved at all? Somewhere near this threshold, a group stands on ground that no longer exists. Perhaps it is a coastal plain, rich with birds and fish, where children learn the routes between freshwater pools and seasonal camps. Perhaps it is a cold valley, where hunters watch reindeer funnel through a pass their coop grandparents knew. Perhaps it is a riverbank beside a lake, swollen by distant meltwater. The people there do not know they are living in a time later scholars will divide with names like Pleistocene and Holocene, Younger Dryas and Boreal, deglaciation and sea level rise. They know only that the land is changing and that survival depends on noticing before it's perhaps too late. In that sense, the end of the Ice Age is not a clean ending. It is a long unraveling. The great white walls shrink, the seas climb, the animals shift, forests advance, grasslands retreat. Human choices become more complicated. The old world does not disappear all at once, and the new one does not arrive fully formed. For generations, people live in between, carrying Ice Age knowledge into landscapes that no longer obey Ice Age rules. And from that uneasy borderland will come drowned countries, vanished giants, new settlements, ancient mysteries, and the first steps toward a world that looks at last unsettlingly like our own. The warming does not begin with a single sunrise over a melting world. It begins as a slow rearrangement of balance, a change in the angle and intensity of sunlight falling across the northern hemisphere, a shift so subtle that no human eye could see its cause, though every generation eventually feels its effects. Snow that once survived the summer begins to fail in certain places. Ice margins lose more mass than they gain. Plants creep into exposed ground. Rivers run harder in spring. Animals follow new growth northward, and people follow animals, water, stone, and memory. The Earth has passed through ice ages before, and the last great glacial cycle is part of a much longer rhythm, driven largely by changes in the planet's orbit, tilt, and wobble. These cycles alter how sunlight is distributed across seasons and latitudes. They don't act alone, and they don't work like a simple switch. A slightly warmer summer in the far north can begin weakening ice. Less ice means less sunlight reflected back into space. Darker land and water absorb more heat. Oceans respond. Greenhouse gases rise. Vegetation shifts. Dust patterns change. The climate system begins amplifying a small orbital push into something large enough to remake continents. But on the ground, none of this looks like astronomy. It looks like mud. At the edges of the ice sheets, frozen ground softens into unstable soil. Streams braid through gravel plains, carrying gray meltwater, thick with powdered stone ground from bedrock by moving ice. Lakes form where ice blocks drainage. Some are small and temporary. Others become inland seas, held in place by ice dams that may last for years or centuries, then fail with terrifying speed. The soundscape changes. There is still wind, still cold, still the long silence of open land. But there is also more water, dripping, cracking, rushing, undermining. The frozen world is learning to flow. For animals, the first warming is not simply relief. It changes the location of food. The mammoth steppe depends on cold, dry, open conditions. And as temperature and moisture patterns shift, its old continuity starts to break apart. In some regions, grass and herb-rich tundra remain. In others, shrubs spread. Later, birch, pine, and other trees begin to claim ground that had once supported open country grazers. Reindeer can adapt to certain changing conditions, but mammoths, woolly rhinos, steppe bison, wild horses, and other large herbivores depend on broad ecological networks. When those networks fragment, the animals don't vanish instantly. Their ranges contract, their numbers thin, isolated populations linger. The evidence remains incomplete, but it suggests not one sudden disappearance everywhere, rather a drawn-out pressure that builds unevenly across the map. For humans, this unevenness matters. A warming planet creates corridors and traps at the same time. Ground released from ice can eventually become new territory, but newly deglaciated landscapes are not immediately welcoming. They can be raw, wet, unstable, and poor in mature resources. Farther south, old hunting routes may still function for a time, but the timing of migrations changes. A herd that once arrived in a valley during a predictable season may begin arriving earlier, later, or not at all. A river crossing used by generations may become deeper and more dangerous. A dry camp near a lake may become marsh. A coastal shelter may find the sea closer every decade. Human groups do not respond as one unified species, making a single decision. They respond locally, creatively, and sometimes unsuccessfully. Some follow herds into new territories. Some intensify fishing, shellfish gathering, birding, trapping, and plant collecting. Some return again and again to resource-rich places where rivers, lakes, forests, and grasslands meet. Some may abandon regions that no longer repay the effort of living there. Archaeology sees these changes indirectly through stone tool traditions, settlement patterns, bones, hearths, isotopes, pollen, charcoal, and the stubborn absences where evidence should be, but isn't. One of the lesser-known details of this transition is how important small things become. The popular imagination often focuses on mammoths and spears, but survival in a warming world may depend just as much on fish runs, hazelnuts, waterfowl eggs, edible roots, berries, freshwater mussels, and the seasonal habits of smaller animals. As environments become more mixed, human diets often broaden. This doesn't mean people are desperate in every case. In some places, diversity is abundance. A river full of fish, a wetland full of birds, and a nearby woodland full of nuts can support people differently from an open plain of migratory herds. But it requires different knowledge. It may reward staying longer in one place. It may encourage storage. It may increase contact and tension between groups drawn to the same reliable locations. The warming also changes movement. In a colder world with lower seas, some routes are open that modern geography hides. People can move across land now submerged. They can occupy plains that are now continental shelf. They can travel through corridors, later blocked by water, forest, or political borders. As ice retreats, new northern lands eventually become available. But rising seas erase others. Migration at the end of the Ice Age is therefore not a simple outward expansion into empty space. It's a constant negotiation between opening and closing worlds. Across Western Eurasia, as climates warm after the last glacial maximum, human populations recolonize lands that had been too harsh or ice-covered. In Britain, for example, people return during warmer phases, though occupation comes and goes with climate pulses. In parts of Europe, cave art traditions change and eventually fade. In the Near East, groups begin using landscapes in ways that will later feed into the first experiments with settled life. In East Asia, Australia, and the Americas, different local stories unfold, shaped by coastlines, mountains, deserts, forests, and rivers. No single timeline can contain them all neatly. Scholars still debate the details of the first widespread human presence in the Americas. But by the end of the Ice Age, people are clearly living across much of the hemisphere. Some routes may have followed interior corridors once ice permitted passage. Others may have moved along Pacific coastlines using boats or shoreline resources, though much of the evidence for early coastal movement may now be underwater. This is one of the great frustrations of the period. The places most attractive to people, near water and food, are often the places least likely to remain visible after thousands of years of sea level rise. Meanwhile, the atmosphere itself is changing. Dust that once blew from cold, dry glacial landscapes begins to decline in some regions as vegetation stabilizes soils. Greenhouse gases rise from glacial lows. Methane increases as wetlands expand. Carbon dioxide climbs as oceans and biosphere shift. These changes are measurable in ice cores, but for ancient people, they appear only through consequences: softer seasons, different plants, unfamiliar animal behavior, altered storms. The planet is not merely warming, it is becoming more complicated. There's a temptation to imagine this warming as a story of progress, as if the end of ice naturally leads to the rise of agriculture, villages, and civilization. But the path is not straight. Warmer doesn't always mean easier. A cold, open steppe full of predictable herds may be safer for a skilled hunter than a dense forest, where large animals are scattered and visibility is poor. A rising sea can turn rich coastal territory into a memory. A wetter climate can bring abundance, but also insects, disease, flood, and rot. A longer growing season can help plants, but it can also change which plants dominate and which animals remain. The people living through this transition are not passive witnesses to climate change. They burn landscapes, hunt selectively, move seeds, transport stones, build shelters, make art, bury their dead, gather at special places, and maintain social networks across distance. Some of their actions may shape local environments in ways difficult to detect today, yet they remain small societies, facing forces beyond their control. No one can stop an ice sheet from melting. No one can hold back a sea that rises generation after generation. No one can command a vanished herd to return. What survives in the record suggests a world in motion long before the famous threshold of 12,000 years ago. The end of the Ice Age is already underway, but it is not smooth, not safe, and not finished. People adjust to warming, then to cold reversals, then to renewed warming. Their world teaches them that climate is not a background. It is an actor. It opens doors, removes flaws, changes the rules of hunger, and turns familiar places strange. Somewhere at the margin of a retreating glacier, the year's meltwater cuts a new channel through gravel and silt. A hunter who knew the old crossing stops at the bank and sees that the river is no longer the same river. Farther south, a child gathers nuts in a patch of woodland where open grass once stretched. On a coast that will one day be drowned, smoke rises from a camp beside tidal flats rich with shellfish and birds. These moments leave little behind: a few stones, a charred seed, a bone split for marrow, a footprint if fortune is unusually kind. But together, they mark the beginning of the great rearrangement. The ice is still immense. The cold can still return. The old animals still move across parts of the world, yet the balance has shifted. The planet has begun to release itself from the frozen architecture of the Pleistocene, and everything alive must answer in its own way. As the ice weakens, the map begins to lose its old certainty. The change isn't visible everywhere at once, and it doesn't arrive with the neatness of a line drawn across a calendar. It happens as 1,000 local disturbances that, when seen together from a distance of 12,000 years, become one of the greatest rearrangements of land and water in the human story. A glacier retreats from a valley and leaves behind raw stone, scraped hillsides, and pools of milky meltwater. A river finds a new course across loose sediment. A lake swells against an ice dam. A coastline shifts. A plain becomes wetter, then marshier, then tidal. The world that Ice Age people know is not simply warming, it is being redrawn. The first thing to understand is that ice is heavy in ways the human mind struggles to hold. An ice sheet several kilometers thick is not just frozen water lying on top of the land. It presses the crust downward. It changes drainage. It stores a planetary ocean on land. When that ice melts, the water must go somewhere, and the land beneath it begins slowly to rise back. This creates a strange geography. At the end of the Ice Age, some places drown because global sea level rises, while other places lift because the burden of ice has been removed. In parts of Scandinavia and Canada, ancient shorelines now stand high above the modern sea, stranded like ghost coasts on dry land. Elsewhere, especially far from the old ice centers, the ocean advances across low plains and buries the evidence of human life beneath mud, sand, and water. This is one of the quiet tragedies of archaeology. The most attractive places for people are often the least likely to survive in the record. River mouths, sheltered bays, lagoons, estuaries, freshwater springs near the coast, rich tidal flats, and lowland plains would have offered food, movement, and seasonal security. Yet many of these places are now underwater. The end of the Ice Age does not merely transform landscapes, it hides them. It takes some of the most important chapters of human adaptation and places them beyond easy reach beneath the North Sea, the Persian Gulf, the Sunda Shelf, the Bering Sea, and countless drowned margins around the world. What survives in caves and inland camps may be only the visible edge of a much larger human world. The rising ocean is not a single flood, although there may be sudden pulses within it. Sea level climbs by more than 100 meters from the low stand of the last glacial maximum to the later Holocene. At times, it rises slowly enough that a shoreline shift might be noticed only across generations. At other times, meltwater pulses may raise seas much faster, turning familiar coastlines unstable within the span of a human lifetime. Scholars still debate the precise timing and sources of some of these pulses, especially where ice sheet collapse, ocean circulation, and regional land movement complicate the picture. But the broad direction is beyond doubt. The sea is coming back. For people living near that moving edge, the consequences are intimate. A camp used by grandparents may become too wet for sleeping. A freshwater pond may turn brackish. A path across a low ridge may become a causeway, then an island chain, then open water. Shellfish beds may move inland as the tide follows the rising sea. Fishing may improve in some places, even as old land disappears. The transformation is not only loss. New estuaries can be rich. New wetlands can draw birds, fish, reeds, and mammals. But each opportunity comes attached to uncertainty. A world built on inherited knowledge becomes harder to predict. Meltwater also changes the inland world. At the margins of the great ice sheets, huge proglacial lakes form, where water is trapped by ice. Moraines, or high ground. Some of these lakes are beautiful in imagination and dangerous in reality. Their surfaces may stretch across vast distances, reflecting cold skies and floating ice. Their shorelines shift as dams weaken or new outlets open. When they drain suddenly, the result can be catastrophic. In North America, enormous glacial lake outbursts carve channels, rearrange river systems, and release fresh water into oceans and seas. In Eurasia, ice-dammed lakes and meltwater routes likewise reshape landscapes in ways still too large, traced by sediments, shorelines, and eroded valleys. No single flood explains the end of the Ice Age, despite many later myths and popular theories. But sudden floods are real parts of this changing world. The planet's rivers become agents of memory and destruction. Meltwater carries silt ground fine as flour beneath glaciers. It builds deltas, fills basins, and lays down varved sediments, thin seasonal layers that scientists can later read like pages in a cold archive. In spring and summer, channels swell. Braided rivers spread across gravel flats, splitting and rejoining in unstable patterns. A crossing known for generations can become deadly. A valley floor can be rebuilt by water in a few seasons. In places where humans return, year after year, the land may no longer preserve the same landmarks. The evidence remains incomplete, but it's easy to imagine how stories of dangerous waters, broken ice, and vanished ground could become part of oral memory. At the same time, vegetation advances into the newly exposed world. The first colonizers of raw ground are not great forests, but tough plants able to survive on disturbed soils, grasses, sedges, dwarf shrubs, mosses, lichens, and pioneer species. Then come shrubs, then trees, where climate and soil allow. Birch and pine often appear early in many northern sequences, though the pattern varies from region to region. Pollen preserved in lake mud and peat gives a remarkable record of this migration. Each layer of sediment contains tiny grains from plants that once released them into the air. Under a microscope, the changing balance of pollen becomes a map of ecological transformation. Open steppe yields to shrub tundra in some places, woodland in others, and eventually denser forests. But the change is patchy. Landscapes do not obey simple boundaries. For Ice Age animals, this patchiness can be fatal or life-saving, depending on the species. Some creatures thrive at ecological edges. Others depend on wide-open ranges. As forests expand, open country grazers lose continuity. As wetlands spread, waterfowl and fish may flourish. As shrubs grow, browsing animals gain ground. Reindeer, elk, deer, aurochs, boar, and smaller game become more important in different regions. Humans notice these shifts, not as abstract ecology, but as meals, skins, tools, danger, and travel. A mammoth disappearing from a valley is not only a change in biodiversity, it is the loss of meat, fat, ivory, bone, hide, story, and status. A forest spreading into open land is not only a habitat transition, it changes how far one can see, how one hunts, how one moves, and where one feels safe. One surprising consequence of the melting world is that it doesn't always become warmer in a straightforward way. Ice retreat can disrupt ocean circulation by releasing enormous quantities of fresh water into the North Atlantic. Fresh water is lighter than salty water, and when enough of it enters the ocean, it can interfere with the sinking of cold, dense water that helps drive major currents. Scientists continue to study how these processes contributed to abrupt climate events near the end of the Ice Age. The system is complex, and no single mechanism explains everything, but the result is clear in the records. Warming is interrupted by sudden cold reversals, and the most famous of these waits like a trap in the story. Before that reversal, however, there is a world of expanding possibility. In many regions, people move into lands that were previously impossible or marginal. The retreat of ice opens routes through Europe and North America. In southern and western Asia, changing rainfall and vegetation alter the availability of wild cereals and other plants. In Africa, lakes and rivers respond to shifting monsoon systems. In Australia and New Guinea, sea level rise begins separating lands that had once been joined across the Sahul continent. In Southeast Asia, the flooding of the Sunda Shelf transforms a huge connected tropical lowland into the island world familiar today. These changes happen over long spans, but they carry human consequences at every stage. The end of the Ice Age is therefore not only a northern story of glaciers, it's a global story of coastlines, rainfall belts, deserts, forests, islands, rivers, and shelves. In some places, the thaw brings more water. In others, it shifts rain away. The Sahara, later famous as a desert, will go through greener phases tied to monsoon changes, though not all at once and not permanently. Lakes expand in places that are now dry. Grasslands appear where sand dominates today. Ancient shorelines mark lakes that no longer exist. Fish bones, harpoons, rock art, and settlement traces hint at people using landscapes modern observers might mistake for timeless deserts. The post-Ice Age world is not merely becoming modern, it is passing through combinations of climate and ecology that have no exact match today. And still beneath all these transformations, human life continues in the small scale of daily need. A person sharpens a blade beside a fire. Someone repairs a hide covering while rain falls harder than expected. Children learn which plants have appeared near camp this year. Hunters return with different animals than their elders once favored. A group debates, perhaps without formal words, whether to follow a familiar route or remain. Near a newly reliable wetland, no written record preserves their decisions. The land records only fragments: charcoal, pollen, bones, tools, footprints, hearthstains, shells, sometimes burials. From these fragments, a picture emerges of people living inside a planet that is rearranging itself faster than tradition can fully absorb. The old Ice Age world is not gone yet. The ice still dominates the north. Cold still has power. Mammoths still survive in some regions. Open landscapes remain. But the future has begun to press in from every direction. From the sea, from the rivers, from the forests, from the shifting migrations of animals, from the instability of ice itself. A person standing on a low coastal plain might see only a wide horizon, birds lifting from marsh grass, and smoke from another camp in the distance. They could not know that the ground beneath them would become seabed, that thousands of years later, people would sail above it, unaware of the paths and graves below. They could not know that their world was becoming invisible. That is the strange power of this moment. The end of the Ice Age creates the stage on which later history will unfold, but it does so by erasing much of the stage that came before. It gives with one hand and takes with the other. It opens forests and buries plains. It releases rivers and drowns coasts. It makes new abundance possible while destroying old certainties. And as the warming continues, the planet prepares for one of its most unsettling reversals, a sudden return of cold, sharp enough to remind every living thing that the Ice Age has not yet surrendered. Just when the warming world seems to be loosening into a new shape, the cold comes back. Not everywhere in the same way, not with the same force in every valley and coastline, but clearly enough to leave its mark across ice cores, lake sediments, pollen records, animal ranges, and human traces. The planet, already moving out of the deep freeze, suddenly hesitates and turns backward. Forests that had begun to spread in some northern regions retreat or stall. Open tundra returns. Winds sharpen. Glaciers in certain mountains advance again. The promise of a gentler climate becomes uncertain. This cold reversal is known as the Younger Dryas, and it remains one of the most dramatic interruptions in the story of the Ice Age's end. It begins roughly 12,900 years ago and lasts for more than 1,000 years, ending around 11,700 years ago, close to the formal beginning of the Holocene. To modern science, those dates come from layered ice, trapped gases, oxygen isotopes, ancient pollen, lake mud, and other records that together reveal a climate system capable of changing with startling speed. To the people living through it, there are no dates, no named periods, no charts. There is only the return of harsher seasons, the failure of expected growth, animals shifting again, and perhaps the unsettling sense that the world cannot be trusted to keep moving in one direction. The name itself comes from a small Arctic alpine flower, Dryas octopetala, whose pollen appears in European sediments from colder conditions. It's a delicate plant with white petals, but in the climate record, it becomes a sign of severity. The younger part distinguishes this cold phase from earlier events marked by similar vegetation. It's a quiet name for a violent idea. A warming planet can suddenly cool again, and it can do so fast enough to matter deeply to living communities. Scholars still debate the exact cause of the Younger Dryas, though one major explanation focuses on meltwater and the North Atlantic. As ice sheets melt, vast quantities of fresh water can pour into the ocean. Fresh water is less dense than salty water, and when enough of it enters key regions, it can disrupt the sinking of cold, salty water that helps drive Atlantic circulation. If that circulation weakens, heat transport changes, especially around the North Atlantic world. The result can be regional cooling, even as the broader planet is moving out of glaciation. This explanation fits much of the evidence, though the precise routes, timing, and volumes of meltwater remain complex and debated. There are other ideas, including the controversial proposal that an extraterrestrial impact, or airburst, helped trigger the Younger Dryas and contributed to extinctions and cultural changes. This theory has attracted popular attention because it offers a dramatic single event: fire from the sky, sudden devastation, a clean cause for a messy world. But the evidence remains disputed, and many researchers do not accept it as the main explanation. The safer and more mainstream picture is less cinematic, but more powerful. The climate system itself, strained by melting ice and shifting oceans, may have been capable of abrupt reversal without needing one simple catastrophe to explain everything. No single explanation fully accounts for every regional pattern, and that uncertainty is part of the mystery. For humans, the Younger Dryas is not a scientific puzzle. It is a lived disruption. In Western Europe, colder and drier conditions alter vegetation and animal availability. In parts of the Near East, the period may bring stress to communities that had begun relying more heavily on wild cereals and local resources. In North America, people are living in landscapes still responding to ice retreat, megafaunal decline, and hydrological upheaval. Across the world, the effects vary, but the lesson is the same. Adaptation cannot be a one-time invention. It has to be repeated, revised, and sometimes abandoned. The Younger Dryas arrives after generations have already adjusted to warming. That is what makes it so consequential. People are not simply continuing old Ice Age patterns unchanged. In many places they have already begun using different habitats, different prey, different seasonal schedules. Some groups may be staying longer in resource-rich areas. Some are exploiting rivers, wetlands, and plant foods more intensively. Then the climate shifts again. A plant community that seemed reliable may shrink. A herd route may change. A water source may freeze longer or behave differently. A place that supported repeated gatherings may become less dependable. In the Levant, this moment becomes especially interesting because it overlaps with the Natufian culture, often discussed as one of the important bridges between mobile foraging and later farming. Natufian communities, beginning before the Younger Dryas, use wild cereals, build more substantial structures in some places, bury their dead with care, and appear to live in larger or more settled communities than many earlier hunter-gatherers. They are not farmers in the full later sense, but they are experimenting with a different relationship to place. When the Younger Dryas brings cooler and drier conditions to parts of the region, it may place pressure on these emerging lifeways. Some scholars argue that this stress encouraged greater management of plants and eventually contributed to agriculture. Others caution that the path is not so direct. The evidence remains incomplete, and farming does not emerge because people simply get cold and hungry one year. It emerges from long interactions among climate, plants, population, knowledge, risk, and social choice. This is one of the great themes of the Ice Age's end. Crisis can force change, but it does not dictate a single outcome. In some environments, people respond to instability by moving more. In others, They settle more firmly around reliable resources. Some diversify their diets. Some intensify the use of a few dependable foods. Some build stronger social networks to survive lean times. Some groups vanish from the archaeological record in a region, which may mean migration, transformation, or simply that their traces no longer preserve well. Archaeology often sees the aftermath more clearly than the decision. The cold reversal also affects animals already under pressure. The great Ice Age herbivores do not all disappear during the Younger Dryas, and it would be misleading to blame the event alone for the extinction of the megafauna. Mammoths, mastodons, giant ground sloths, horses in the Americas, and other large animals follow different regional timelines. Some vanish before, during, or after this period, depending on species and place. Climate stress, changing vegetation, human hunting, reproductive rates, habitat fragmentation, and ecological cascades all likely play roles. But the Younger Dryas adds instability at a moment when many systems are already strained. A population reduced by habitat loss may be more vulnerable to hunting. A species adapted to open steppe may suffer when warming fragments its world, then suffer again when cold returns in altered form. No single pressure needs to act alone. A lesser-known but haunting detail is that the Younger Dryas ends extremely abruptly in some climate records. After more than a millennium of cold, temperatures in parts of the North Atlantic region rise sharply, perhaps within decades. Ice core evidence from Greenland suggests a rapid transition into warmer Holocene conditions. This means that humans near the end of the Younger Dryas may experience not only cold, but then another powerful shift toward warmth. Imagine the accumulated knowledge of several generations shaped around renewed cold, only for the world to change again. It's not the speed of a storm, but it is fast by the standards of landscapes, forests, and inherited seasonal life. The Younger Dryas also complicates the idea of memory. If oral traditions preserve environmental change, then people living through these centuries may carry stories not simply of warming, but of reversal. Elders could remember milder times described by their own elders, while younger generations know harsher cold as normal. Then their descendants may witness warming again. Such experiences do not leave written testimony, yet they may shape how people understand land, risk, and the reliability of the world. The record does not allow us to reconstruct their beliefs with confidence, but it would be strange to imagine that such instability left no mark on thought, ritual, or social life. By the end of the Younger Dryas, the Ice Age is truly losing its grip. The cold has returned, but it has not restored the old world. The great ice sheets are diminished. Sea level continues its long rise. Many ecosystems have already been reorganized. Human groups have learned painfully and creatively that survival depends not on preserving one perfect way of life, but on changing without losing memory. When the final warming arrives, it does not bring back the mammoth steppe in its old form. It carries the planet into something new, and so the Younger Dryas stands like a dark hinge between worlds. Behind it lies the Pleistocene with its ice sheets, exposed shelves, giant animals, and open cold landscapes. Ahead lies the Holocene, warmer, wetter in some places, more forested in many, and eventually crowded with villages, fields, herds, temples, roads, kingdoms and cities. But at the hinge itself, nothing is guaranteed. The people alive then inhabit a planet that has already betrayed expectations once, and may do so again. They live with the knowledge that warmth can fail, rivers can change, animals can vanish, and the ground beneath a familiar life can become uncertain. The Ice Age does not end like a candle being blown out. It ends like a struggle. Warmth advances, cold returns, ice retreats, water rises, forests wait at the edges. Animals search for shrinking worlds, and humans keep moving through the confusion, with tools in their hands and memory in their minds. The Younger Dryas is the last great warning from the old climate system. After it, the thaw will not stop. When the old cold world begins to break apart, some of its largest creatures go with it, not all at once, not everywhere in the same year, and not in the simple dramatic way that later imagination prefers, but steadily enough that the disappearance becomes one of the great shadows at the end of the Ice Age. Across continents, animals that had defined landscapes for tens of thousands of years begin to vanish from ordinary human experience. Mammoths thin from the open steppe. Mastodons disappear from woodlands and wetlands in North America. Giant ground sloths, some as large as small elephants, fade from the Americas. Saber-toothed cats, American lions, short-faced bears, giant beavers, glyptodonts, and ancient horses vanish from places where they had once belonged. In Australia, much of the great megafauna had already disappeared earlier, but the larger pattern remains haunting by the time the Holocene world settles into place. The planet has lost many of its giants. The word extinction can sound clean, almost administrative, as if a species simply stops existing at a marked point on a chart. On the ground, it would have felt more like absence spreading. A herd that once arrived every year comes less often. Tracks become rare. Bones remain in old camps, but fresh kills become memories. Children hear about animals they have never seen. Hunters who learned the habits of massive prey find that their knowledge no longer fits this land. The disappearance of a giant animal is not only a biological event. It changes diet, tools, stories, risk, status, and the emotional shape of a landscape. The woolly mammoth is the emblem of this vanishing world. But even its story is not simple. Mammoths had survived earlier climate swings. They were not fragile relics, doomed by the first hint of warmth. They lived across immense territories in Eurasia and North America, adapted to cold, open environments, feeding on grasses, sedges, herbs, and shrubs. Their bodies were built for the Ice Age. Thick fat, long hair, small ears, curved tusks, and a life tied to the productivity of the mammoth steppe. As that steppe fragmented under warming, moisture shifts, shrub expansion, forest growth, and altered snow patterns, mammoth populations faced shrinking and increasingly isolated habitats. Some mainland populations disappeared near the end of the Pleistocene, while small island populations survived much longer, including mammoths on Wrangel Island in the Arctic, until only a few thousand years ago. That late survival is a lesser-known detail, with a strange emotional force. While pyramids were being built in Egypt, the last mammoths may still have been walking on a remote northern island. But climate alone does not fully settle the question. Humans were present, skilled, and increasingly widespread. They hunted large animals where possible, used their bones and ivory, and understood their movements. In some regions, archaeological sites preserve evidence of mammoth butchery or hunting. In others, direct evidence is scarce. Large animals reproduce slowly, and even low levels of hunting can place heavy pressure on populations already stressed by habitat change. A mammoth cow cannot replace herself quickly if calves are lost or adults are killed. A small, fragmented group can collapse from pressures that a vast, healthy population might absorb. No single explanation fully accounts for the extinction of every species across every continent. But the combined force of climate change and human pressure remains the mainstream center of the debate. The same complexity surrounds the mastodon. Unlike mammoths of the open steppe, mastodons often browsed in woodlands and wetlands, feeding on twigs, leaves, and conifer material. Their disappearance in North America cannot be explained by the exact same habitat story as the mammoth. They lived in different ecological spaces, yet they too vanished near the Great Transition at a time when climate, vegetation, hydrology, and human presence were all changing. Some mastodon kill sites show human involvement, but not enough to imagine people simply sweeping across the continent and slaughtering every giant animal in sight. The truth is likely more difficult and more unsettling. Ecosystems were under stress, and humans became a new predator within systems already losing resilience. In South America, the losses are even more astonishing. Giant ground sloths ranged from relatively modest forms to immense animals with massive claws, powerful limbs, and slow but formidable bodies. Glyptodonts, relatives of armadillos, carried heavy armored shells like living fortresses. Toxodonts, strange heavy herbivores with no close modern equivalent, moved through grasslands and wetlands. Horses and proboscideans disappeared. Predators that depended on large prey also declined. Here again, timing varies, evidence is uneven, and scholars still debate the balance of climate and human impact. But the ecological result is clear. The Americas, after the end of the Ice Age, are missing much of their former size. The disappearance of large animals has consequences beyond the animals themselves. Giants are ecosystem engineers. Mammoths break branches, knock down trees, disturb snow, spread seeds, fertilize ground with dung, and keep landscapes open through grazing and trampling. Large herbivores shape vegetation not only by eating it, but by moving nutrients across distance. Predators follow them. Scavengers depend on their carcasses. Insects live in dung. Plants adapt to being browsed, trampled, dispersed, and disturbed. When giants disappear, the land changes again. Forests may spread more easily. Fire regimes may shift. Nutrient cycles alter. Smaller animals inherit a different world. Extinction is not a subtraction from a stable picture. It's a reworking of the whole frame. There's a sharp irony here. Humans at the end of the Ice Age are often imagined as small bands dwarfed by nature. And in many ways they are. They cannot control climate. They cannot command glaciers. They cannot prevent sea level rise. Yet they may still have enough power in the right conditions to help push vulnerable animal populations over the edge. This is not because they are modern industrial destroyers. It's because intelligence, cooperation, projectile weapons, fire, tracking, social learning, and persistence make humans ecologically unusual. A small number of people can have a large impact when prey animals have never faced such hunters before, or when those prey are already stressed by environmental change. Still, it's important not to flatten Ice Age people into villains of extinction. They are also surviving. They hunt because meat, fat, hide, sinew, bone, and ivory matter. They kill within worlds of hunger, danger, ritual, and necessity. They may honor animals, fear them, depend on them, and understand them with intimacy. The archaeological record gives us cut marks and broken bones more easily than it gives us belief. What survives suggests practical skill. What is missing is the full emotional and spiritual relationship between people and the animals they killed. It would be too simple to imagine indifference. It would also be too simple to imagine perfect harmony. The extinctions do not strike every continent equally. Africa retains more large mammals, likely because many species there evolved alongside humans and earlier hominins over much longer spans, adapting to human predation gradually. Eurasia loses many forms but keeps others. The Americas suffer dramatic losses after humans arrive and climates shift. Australia's major losses occur earlier, with debates continuing over the roles of climate, fire, and human arrival. Islands, when later settled, often prove especially vulnerable, though many of those extinctions come much later than the Ice Age's end. This global unevenness matters because it shows that extinction is not one event with one cause. It is a pattern produced by timing, ecology, human arrival, climate instability, and the vulnerability of particular species. The Younger Dryas adds another layer. Cold returns, then warmth returns sharply. Vegetation reorganizes. Water systems shift. Habitats fragment. For a species already reduced, such rapid oscillation can be devastating. A population may survive one stress, but not the next. A herd can endure hunting under stable conditions or climate change without hunting, but the combination can be lethal. This is why many researchers now favor mixed explanations over single-cause arguments. The old debate of climate versus humans has not disappeared, but it has become more nuanced. The question is often not which cause matters, but how causes interact. For the humans watching these changes, the vanishing giants may reshape more than subsistence. In Ice Age art, large animals dominate the imagination. Cave walls and carved objects preserve mammoths, bison, horses, lions, rhinos, bears, and other powerful beings. These images are not simple hunting records. Their meanings remain uncertain, and scholars still debate whether they relate to ritual, memory, identity, teaching, cosmology, or experiences we cannot reconstruct. But when major animals disappear, the symbolic world must change too. A creature can survive in story after it vanishes from the land, but the story itself changes when no living person has seen it. There is something profoundly quiet about the final stages of extinction. The last mammoth on a mainland plain does not know it is the last. The last mastodon, moving through a North American wetland, carries no title. The last giant sloth leaves tracks that rain erases. Extinction becomes visible only afterward, when absence has lasted long enough to become permanent. For ancient people, there may have been rumors from distant groups that certain animals still lived elsewhere, beyond mountains, across rivers, far to the north. Sometimes those rumors would have been true for a while. Refugia existed. Isolated populations lingered. The world did not lose its giants evenly, going out across a vast, dark map. By the time the Holocene takes hold, the relationship between humans and large animals has changed. In some regions, people turn more heavily towards smaller game, fish, birds, shellfish, and plants. In others, surviving large animals remain important. But the age of the great Ice Age beasts has passed. Giants shrink or transform. Mixed environments spread. The human diet broadens in many places, and with it come new tools, new settlement patterns, new social pressures, and eventually new experiments with managing plants and animals. The vanished giants leave behind bones in tar pits, frozen carcasses in permafrost, tusks eroding from riverbanks, footprints hardened in ancient mud, and images on cave walls. They also leave a question that has never fully stopped troubling us. Did they disappear because the climate changed too quickly, because humans hunted too effectively, because ecosystems lost balance, because all of these pressures converged at once? The evidence points not to a single clean answer, but to a world under strain from many directions. And perhaps that is why their disappearance still feels so close. The end of the Ice Age is not only a story of melting ice and rising seas. It is a story of silence entering the landscape, where enormous life had once moved. It is the moment when humans, still few in number compared with later ages, begin to inhabit a world noticeably altered by their presence, even as they themselves are being driven by forces far larger than any campfire, spearpoint, or trail. The giants vanish into the boundary between climate and culture, between natural change and human action. They become the first great absence of the New World. For the people living through the end of the Ice Age, survival is not a theory about climate. It is a sequence of choices made in cold air, wet ground, failing light, and hunger. A group wakes before dawn beside a river that has shifted since the last season. Ash lies under a thin skin of frost. Hides are stiff. Tools are checked by touch. Somewhere beyond the camp, animals are moving, but perhaps not the same animals, not in the same direction, not at the same time remembered by the old hunters. The world has not ended, but it has become less predictable, and unpredictability is one of the oldest human enemies. Hunter-gatherer life at this threshold is often misunderstood, because the word wandering is too easily attached to it. These communities are not drifting randomly across empty land. They move with purpose, within remembered territories, along seasonal circuits shaped by water, stone, plants, animals, shelter, weather, and relations with other groups. A camp may be temporary, but the landscape is not unknown. It is layered with memory. A ridge may be where reindeer were once watched. A spring may be where people return in dry months. A cliff may supply the right stone. A sheltered hollow may hold hearths beneath new ash. Even when nothing is written, the land is full of instructions. The trouble is that around the end of the Ice Age, some of those instructions begin to fail. A place that once offered open views becomes crowded with shrubs. A valley that once funneled herds becomes blocked by wet ground. A lake that once provided fresh water grows larger, colder, or unstable because meltwater feeds it from far away. A coastal camp may remain rich for a time, then slowly surrender to the sea. In such a world, human flexibility becomes more valuable than simple tradition. But flexibility has costs. It requires experimentation. It risks mistakes. It can strain relations between generations, because the knowledge of elders remains precious, yet not always sufficient. Tools change in response to these pressures, though rarely in a neat line from simple to advanced. Late Ice Age and early post-Ice Age technologies show remarkable regional variety. In some places, hunters make finely worked projectile points suited to large game. In others, microliths become important. Small, sharp stone pieces set into wood or bone shafts to create composite tools, arrows, barbs, or cutting edges. Such tools are efficient, repairable, and adaptable. A broken point does not always require making an entirely new weapon. A small insert can be replaced. This is the kind of practical intelligence that rarely looks dramatic in museum cases, but matters deeply in a changing world. A tiny blade can be the difference between a successful hunt and a wasted day. The spread of bows and arrows in some regions, along with traps, nets, harpoons, fish hooks, and other specialized equipment, reflects a broadening relationship with the environment. The old image of Ice Age people living almost entirely by hunting mammoths is far too narrow. As open landscapes fragment and large prey become less reliable, many groups intensify their use of fish, birds, small mammals, nuts, seeds, roots, shellfish, and seasonal plant foods. This does not mean every group becomes poor or desperate. In some places, the new mosaic of habitats creates extraordinary richness. Wetlands can be crowded with life. Rivers can pulse with fish. Woodlands can offer nuts, fruit, fuel, fibers, and game. But abundance in such environments is often seasonal and scattered. It rewards planning, storage, and detailed timing. Storage is one of the quiet revolutions of this period. To store food is to change one's relationship with place and time. Dried fish, smoked meat, cached nuts, seeds, and other preserved resources allow people to remain longer in a favorable location or survive lean stretches without moving immediately. But storage also creates new problems. Stored food can be stolen, spoiled, guarded, traded, shared, or controlled. It may encourage more permanent structures. It may increase social obligations and inequalities. The evidence remains incomplete, and storage leaves uneven traces. But where it appears or is inferred, it hints that survival is becoming less purely mobile in some regions and more tied to particular places. The human body also records adaptation. Bones, teeth, isotopes, and ancient DNA reveal changing diets, movements, and relationships. Though each form of evidence must be interpreted carefully, chemical signatures in bones can show whether people relied more on marine foods, freshwater fish, terrestrial animals, or certain plant resources. Teeth can preserve stress markers from childhood hardship. Ancient DNA can show population movements, mixing, and continuity. Yet no skeleton contains a complete life. What survives in the record suggests broad patterns, but individual experience remains mostly beyond reach. A person may appear to science as a dietary signal or genetic ancestry, while their actual life was made of fear, skill, affection, loss, and weather. At the edge of this changing world, social networks may be as important as tools. A small group alone is vulnerable. Wider connections allow exchange of mates, information, raw materials, ornaments, techniques, and refuge. Long-distance movement of stone, shells, pigments, and decorative objects shows that Ice Age and post-Ice Age people often lived within social worlds larger than their immediate camps. These networks may become even more important when climates shift. If herds fail in one region, information from another may matter. If a familiar territory becomes less reliable, kinship or alliance may open another. A bead, a blade style, or a shared burial custom can hint at relationships that archaeology can barely glimpse. But contact also carries tension. As coastlines shrink and productive zones change, groups may find themselves drawn toward the same resources. River mouths, lake edges, migration bottlenecks, and nutritious woodlands can become places of repeated gathering. These places may encourage exchange, ceremony, marriage, and cooperation. They may also encourage competition. Evidence for violence exists in some late Pleistocene and early Holocene contexts, though it varies widely and should not be exaggerated into a universal war of all against all. Still, the possibility is real. When reliable resources become concentrated, human relations can become more complicated. The end of the Ice Age is not only an environmental transition, it is a social one. One lesser-known aspect of this period is how deeply people may have managed landscapes before. Agriculture in the formal sense. Fire, selective harvesting, transplanting useful plants, encouraging certain habitats, and returning seasonally to productive patches can all blur the line between wild and cultivated. Hunter-gatherers are not simply taking what nature gives. They often shape the conditions under which resources appear. In some environments, controlled burning can maintain open areas, attract game, or encourage edible plants. In others, repeated harvesting and seed dispersal may alter plant communities over time. Scholars still debate how far such practices went in different regions, but the old boundary between foraging and farming is increasingly seen as a wide, messy zone rather than a wall. This matters because the people at the edge of the Ice Age are not waiting to be transformed by agriculture. They are already experimenting with ways of making landscapes more predictable. The later domestication of plants and animals does not come from ignorance suddenly replaced by invention. It comes from long familiarity, pressure, opportunity, and thousands of small acts repeated across generations. A seed gathered near camp may fall in disturbed soil. A useful plant may be protected rather than uprooted. A patch may be revisited, tended, burned, or cleared. At first, none of this needs to look like farming. It looks like knowing a place well enough to make it slightly more generous. Yet, mobility remains crucial for many communities. To move is not failure, it is strategy. When animals shift, people move. When water fails, people move. When social tension rises, people move. When seasons change, people move. The difference is that movement now happens through landscapes more varied and unstable than before. Some groups may shorten their seasonal rounds, returning more often to central places. Others may widen their range to compensate for uncertainty. Some may split for part of the year and gather again when resources peak. The record of hearths, tools, bones, and shelters gives only fragments of these rhythms. But even fragments show adaptability rather than chaos. Clothing, shelter, and daily craft also adjust. In colder pulses, tailored garments remain essential, sewn with bone needles and sinew thread. In wetter or more forested environments, shelters may use more wood, bark, reeds, brush, or plant fibers. Containers become increasingly important, where plant foods, fish, and gathered resources play larger roles. Baskets, nets, mats, bags, and wooden tools rarely preserve, which means much of human technology is missing from the archaeological record. Stone survives and therefore dominates museum displays. But ancient life was never made of stone alone. It was made of perishable genius. Cordage, knots, fibers, skins, handles, glues, traps, boats, and memory. Boats deserve special attention because rising seas and drowned coasts can hide their importance. By the end of the Ice Age, Humans had already reached Australia tens of thousands of years earlier, which required sea crossings. Coastal and riverine travel almost certainly mattered in many regions, even where direct evidence is scarce. Simple watercraft made from wood, bark, reeds, or skins would rarely survive. Yet they may have opened shorelines, islands, estuaries, and river networks to human movement. The absence of preserved boats should not be mistaken for absence of seafaring skill. The evidence remains incomplete. But the geography itself strongly suggests that water was not only a barrier, it was a road. Inside this world of adaptation, belief and ritual do not stand apart from survival. Burials, ornaments, pigments, carved objects, animal imagery, and special gathering places suggest that people meet environmental uncertainty with social and symbolic life, not only with tools. A burial may anchor a group to a place. A ritual may bind communities during seasonal gatherings. An animal image may hold meanings about power, danger, memory, or identity that cannot be reduced to calories. When landscapes change, these symbolic systems may change too. The disappearance of certain animals, the drowning of certain places, and the arrival of new resources could all reshape how people understand the world around them. The end of the Ice Age, therefore, places humans at an edge in more than one sense. They stand at the edge of glaciers, forests, coasts, and new climates. They also stand at the edge of new social possibilities. Some communities remain highly mobile, some become more settled, some rely more heavily on aquatic resources, some intensify plant use, some build larger gathering places, some maintain old traditions while quietly altering the habits beneath them. There is no single human response, because there is no single human environment. And this is what makes their survival remarkable. They do not know they're entering the Holocene. They do not know that later people will look back and search for the origins of farming, villages, monuments, inequality, disease, and civilization in their choices. They are not trying to begin history. They're trying to get through a dangerous season, to keep children alive, to find food where it can still be found, to remember what remains useful, and to let go of what the land no longer supports. Somewhere in this unsettled world, a group returns to a place known by its elders and finds it changed. The open view is broken by young trees. The old animal path is faint. The river has eaten part of the bank where hearths once lay. But there are fish in the shallows, berries near the slope, birds in the reeds, and workable stones still weathering from the hill. So the group stays for a while. Fires are lit, nets are repaired. A child is shown how to split a small blade from a prepared core. Someone remembers when the valley looked different. Someone younger learns it as it is. Between memory and necessity, a new way of living begins to take shape. Some of the most important countries of the Ice Age are missing from the map because they are underwater. They're not mythical islands or fantasy continents, but real plains, valleys, river systems, marshes, forests, hunting grounds, and coastlines that existed when the seas were lower and the world held so much of its water in ice. People walked there, animals grazed there, fires burned there. Children may have learned the paths between camps there, and today, in many cases, ships pass over them without pause, while trawlers scrape bones and antlers from the seabed, as if the ocean itself is remembering what it buried. This loss is one of the great distortions in how we understand the end of the Ice Age. Archaeology is strongest where evidence survives, and evidence survives unevenly. Caves endure. Upland shelters endure. Just human landscapes would have been coastal lands, river mouths, estuaries, lagoons, and broad plains near water. These are exactly the places most likely to vanish as sea level rises. So the record we see is not the whole human story. It is the story that escaped drowning. Doggerland is perhaps the most famous of these lost worlds, where the North Sea now separates Britain from mainland Europe. There once stretched a wide lowland of rivers, lakes, marshes, wooded patches, and open ground. It was not a narrow bridge used only for crossing. It was a lived landscape, a place with its own ecology, and likely its own human histories. At different times, depending on climate and sea level, animals moved across it, and humans followed or settled within it. Mammoth bones, deer remains, worked flints, barbed points, and other finds dragged from the North Sea hint at a submerged archive scattered across the seabed. To imagine Doggerland correctly, it helps not to picture a single static landmass. It changes over time. At the height of glaciation, when sea levels are much lower, the exposed land is extensive. As the climate warms and the ocean rises, it shrinks, fragments, and transforms. Low plains become wetlands. River valleys become estuaries. Higher ground becomes islands. Eventually, the connection between Britain and the continent disappears. Still, even remaining islands are swallowed or reshaped. One of the most discussed possible final blows is the Storegga slide tsunami, triggered by a massive submarine landslide off Norway around 8,200 years ago. It may have sent waves across parts of the North Sea basin, striking already vulnerable coasts. Scholars still debate exactly how much this tsunami contributed to the final loss of Doggerland, because sea level rise had already done most of the long work. But as an image, it's hard to forget. A drowned land already fading, then a sudden wall of water moving across its last margins. Doggerland matters because it forces a change in perspective. Britain's later island identity is a recent condition in deep time. For much of human prehistory, the land now beneath the North Sea was not empty water, but connective tissue. Animals, plants, and people moved through it. Ideas and technologies may have passed across it. Genetic histories may carry the traces of populations that once lived on ground now unreachable without sonar, cores, dredges, and underwater archaeology. When later maps show a clean channel between Britain and Europe, they hide a long period when there was no such division. Far to the northeast, another lost world connects Asia and North America. Beringia is often called a land bridge, but that phrase makes it sound like a corridor, a temporary strip of land whose only purpose is to let people cross from one continent to another. In reality, Beringia was vast. During lower sea levels, it included parts of what are now Siberia, Alaska, and the exposed floor of the Bering and Chukchi seas. It was not buried under thick ice, like much of northern North America. It supported steppe tundra environments, animals, plants, and human possibilities. For some researchers, Beringia may even have served as a refugium where populations lived for extended periods before moving deeper into the Americas, though the details remain debated. Here again, the sea hides the center of the story. If people lived on the exposed Bering landmass, many of their camps may now lie beneath shallow Arctic waters. The same is true for possible coastal migration routes along the Pacific edge of the Americas. If early groups moved by boat or along shorelines using kelp forests, fish, shellfish, birds, and marine mammals, then much of the evidence has been submerged by rising seas or disturbed by later coastal processes. The absence of abundant early coastal sites does not prove such routes were unimportant. It may simply mean that the places we most need to study are now underwater. In Southeast Asia, the Sunda Shelf offers another vast example. During the Ice Age, lower sea levels connected large areas of what are now islands and shallow seas. Sumatra, Java, Borneo, and the Malay Peninsula were part of a larger landmass known as Sundaland. Rivers crossed plains now drowned beneath the Java Sea and South China Sea. Forests, savannas, wetlands, and coastal habitats shifted with climate and sea level. Human groups and animals moved through a geography very different from the modern island world. As the ice melted, the sea returned and broke this land into the archipelagos known today. The transformation did not just change coastlines, it changed migration. isolation, biodiversity, and cultural possibilities. The flooding of Sunderland is especially important because tropical environments rarely preserve archaeological evidence as generously as colder or drier regions. Organic materials decay quickly, dense vegetation hides sites, rising seas bury lands. Yet this region sits near some of the most important routes in human dispersal, including the much earlier movement towards Sahul, the Ice Age landmass of Australia and New Guinea. By 12,000 years ago, the geography is still changing dramatically. New islands, straits, and coastlines are forming. Communities that once moved across connected land must adjust to a more maritime world. Boats, coastal knowledge, and island networks likely become increasingly important, even where direct evidence is sparse. Other drowned landscapes lie beneath the Persian Gulf, which during lower sea levels exposed broad plains cut by rivers. Some researchers have suggested that this basin may have held attractive habitats for human groups before the sea filled it, though the timing, density, and cultural significance remain uncertain. The Gulf's later flooding would have transformed regional movement and settlement possibilities. Similar stories can be told around the Mediterranean, the Black Sea margins, the Adriatic, the Gulf of Carpentaria, the coasts of India, Japan, Korea, China, Africa, and the Americas. The modern coastline is only the latest draft of a much older text. These submerged worlds also complicate the search for the origins of settled life. It's possible that some early experiments in more permanent occupation, fishing economies, plant use, storage, and social gathering occurred along coasts now drowned. Inland sites may therefore overrepresent one part of the transition. This does not mean hidden cities lie beneath every shelf, or that advanced lost civilizations vanished under the sea. Those popular claims usually run far beyond the evidence. But it does mean that ordinary prehistoric lives, which are often more important than legends, were swallowed on a massive scale. The missing record is not proof of fantasy, it is proof of loss. Underwater archaeology is slowly recovering pieces of that loss. Submerged forests, peat beds, ancient river channels, animal bones, stone tools, and preserved landscapes can sometimes be mapped or sampled. In certain places, divers find worked wood, fish traps, or occupation surfaces. Remote sensing reveals buried valleys. Sediment cores preserve pollen, microfossils, and environmental DNA. Fishing fleets have unintentionally retrieved some of the most evocative finds, including bones of Ice Age animals and human-made tools. Yet working underwater is difficult, expensive, and often limited by poor visibility, currents, sediment movement, and the sheer size of continental shelves. The evidence remains incomplete, not because the story is small, but because the archive is enormous and hard to reach. There is also a human sadness in these drowned lands that science can describe, but not fully measure. A place can be lost gradually and still be catastrophic. If a shoreline retreats year after year, people may move camps inland, adapt to new fishing grounds, and tell stories of where the land used to extend. But over generations, graves may be abandoned, sacred places left behind, paths broken, and memories stretched until they become legend or disappear altogether. The rising sea does not need to arrive as a single enormous flood to transform identity. Slow loss can be relentless. It gives people time to move, but not always time to preserve what a place meant. At times, the change may have been sudden enough to terrify. Storm surges, tsunamis, ice dam failures, collapsing shores, and rapid meltwater pulses could all create moments when water seemed to attack. Of the ocean, after the deep freeze, Conomas donated lens, and rapid meltwater, Comonas to Duronas, Comonas to Duronas, Hataduronas, Condavurs. Thousands of years becomes temporary, and a hill becomes an island becomes a shoal. A shoal becomes a hazard beneath waves. The people who knew it are gone long before history begins. But the shape of the seabed still carries their vanished geography. What is most unsettling is that the drowned world was not marginal. It may have been central. Modern humans have always been drawn to edges. River edges, forest edges, coast edges, ecological borders where many resources overlap. The end of the Ice Age drowned countless edges.
That means our picture of late Ice Age human life may be biased toward the places that survived, above the waterline. We study the remaining fragments and try to infer the missing whole, like reconstructing a song from the notes that were not washed away. Somewhere beneath the North Sea, a river once curved through low ground, where deer came to drink. Somewhere beneath the Bering Sea, wind moved over steppe now covered by cold water. Somewhere beneath the Java Sea, a channel carried rain through a tropical plain that no longer has a name. People may have stood in those places and believed them permanent, because every generation does. They may have buried their dead there, taught children there, marked seasons there, and watched animals cross horizons that now belong to fish. The end of the Ice Age did not only melt glaciers, it drowned memory. It took vast, inhabited landscapes and lowered them into silence, leaving later humans to mistake the modern coastline for something ancient and fixed. But the true map of the human past is larger, stranger, and more unstable. Beneath the waves lie the missing rooms of prehistory, and in them, perhaps some of the answers to how people endure the long thaw. The sea does not need to rise like a wall to destroy a world. Often, it arrives with patience. It enters through the lowest places first, through tidal channels, marsh edges, river mouths, lagoons, and the hidden seams where fresh water and salt water meet. It turns firm ground soft. It pushes reeds inland. It poisons freshwater pools with salt. It changes the taste of wells and the behavior of fish. It redraws the safe places to sleep, then the places to hunt, then the places where ancestors lie buried. By the time waves cover the old camp completely, the people may already be gone, but the loss has been happening for generations. This is what makes post-Ice Age sea level rise so difficult to imagine. Modern minds often look for a single flood, a clean catastrophe, a day when everything disappears. There were sudden floods in the age of melting ice, and some were enormous. Ice-dammed lakes failed. Tsunamis struck vulnerable coasts. Storms pushed water over low shores. Meltwater pulses may have raised global seas at rates that would have been deeply noticeable across a human lifetime. But much of the Great Drowning was slower, and in some ways that makes it more haunting. It was a disaster with time to become familiar. At the maximum of the last glaciation, the ocean stood far lower than it does today, because so much water was locked in ice sheets. As those ice sheets melted, sea level rose by more than 100 meters overall, though the pace varied. Some centuries saw slower advance, others saw faster jumps. One famous episode, often called Meltwater Pulse 1A, occurred earlier than the final threshold into the Holocene, but it shows the scale of what the system could do. Huge volumes of meltwater entering the ocean raised sea level rapidly by geological standards. Scholars still debate the exact sources and timing of such pulses because ice sheets do not leave simple signatures when they collapse. But the central fact remains. Coastlines around the world were moving. For a coastal community, even a small vertical rise in sea level can mean a large horizontal loss if the land is flat. A low plain may surrender kilometers to the sea for every meter of rise. Tides push farther inland. Storms reach places once protected. Estuaries widen. Sand barriers migrate. The shoreline is not a line but a zone of instability, and humans living within that zone must constantly renegotiate it. They may move houses or shelters upslope, shift fishing places, abandon shell beds, or follow new lagoons as they form. They may gain access to new marine resources, even as they lose old land. Sea level rise is destruction, but it is also transformation, and people are drawn to the new edges it creates. This is why flood memories are so tempting to discuss, and so difficult to prove. Around the world, later cultures preserve stories of great floods, drowned lands, or seas that came over inhabited places. Some may encode memories of real post-glacial sea level rise, local tsunamis, river floods, or coastal disasters. Others may be symbolic, theological, political, or shaped by much later events. The evidence remains incomplete, and it's risky to draw a straight line from any ancient myth to a specific Ice Age shoreline. Oral traditions can preserve remarkable environmental memories, but they also change as they pass through time. Still, the possibility that some flood stories carry distant echoes of real landscape loss is not easily dismissed. Human beings remember water. One of the most dramatic examples often discussed is the Black Sea flood hypothesis, which proposes that rising Mediterranean waters may have poured into the Black Sea basin after the Ice Age, rapidly expanding it and perhaps influencing later flood traditions. It's a fascinating idea, but the details remain debated. Researchers disagree over the timing, speed, scale, and cultural impact of the event. It may have been less sudden than once imagined, or different in character from popular versions of the story. This is a useful warning. The end of the Ice Age produced real floods, real drowned landscapes, and real human disruption. But not every legendary flood is a direct memory of one spectacular prehistoric event. The past is usually messier than the stories built from it. The same caution applies to claims of advanced lost civilizations swallowed by the sea at the end of the Ice Age. Rising oceans certainly drowned human landscapes, and some of those landscapes may have contained complex hunter-gatherer communities, ritual sites, seasonal aggregation centers, and early experiments in settlement. But there is no solid evidence for a global advanced civilization destroyed in one cataclysm around 12,000 years ago. Such claims often take the genuine mystery of submerged prehistory and stretch it beyond what the evidence can support. The real story needs no exaggeration. Ordinary human worlds drowned by rising seas are already profound enough. Along many coasts, shell middens become some of the clearest signs of human adaptation to changing shorelines. These heaps of discarded shells, bones, charcoal, tools, and other debris can look humble, but they are archives of diet, seasonality, technology, and settlement. They show people returning to rich coastal places, harvesting shellfish, fishing, collecting birds, and building patterns of life around marine abundance. Yet older middens from lower shorelines may be underwater, meaning the surviving examples could represent only later chapters of a much longer coastal tradition. What appears to be a sudden rise in coastal adaptation may partly be a preservation illusion. The earliest and perhaps most important evidence may be drowned. Estuaries deserve special attention because they are among the richest and most changeable environments created by rising seas. Where rivers meet the ocean, nutrients gather, fish spawn or migrate, birds feed, shellfish beds expand, reeds and marsh plants provide materials as well as food. Fresh water, brackish water, and salt water create overlapping habitats for humans. These places can be extraordinarily productive. They may support longer stays, larger gatherings, and more predictable seasonal returns. But they are also unstable. Channels shift, storms reshape banks, saltwater intrusion changes plant communities. A productive estuary is both a gift and a warning. It exists because the sea is moving into the land. In some places, the advancing sea may have forced people into closer contact. As lowlands disappeared, groups that once ranged across wider territories could find themselves compressed into narrower habitable zones. This does not automatically mean conflict, but it increases the importance of boundaries, alliances, marriage networks, and shared access. A fishing ground, a freshwater spring, a stone source, or a safe landing place may become more valuable when surrounding land is gone. Archaeology can sometimes detect signs of increased territoriality through cemeteries, repeated settlement, distinctive artifact styles, or defensive locations. But interpretation is difficult. What survives in the record suggests that the social consequences of drowning were as important as the physical ones. The great flooded coasts also changed the movement of animals. As land bridges narrowed and vanished, populations became isolated. Britain separated from the continent. Tasmania separated from mainland Australia earlier in the post-glacial rise. New Guinea and Australia became distinct landmasses as Sahul fragmented. Islands formed where hills remained above water. Animal ranges broke apart.
Human groups, too, became separated or had to rely more heavily on watercraft to maintain contact. The sea created barriers, but also corridors for those who could navigate it. A shoreline world rewards different skills than an inland steppe. Knowledge of tides, currents, reefs, winds, fish behavior, and boat-making becomes increasingly powerful. Boats, however, are frustratingly invisible. A simple dugout, bark canoe, reed raft, or skin boat can transform human geography, but it rarely survives for thousands of years, especially along drowned coasts. This means that ancient maritime skill is likely underestimated. People had crossed seas long before the Ice Age ended, as the settlement of Australia proves. By the time coastlines were rising rapidly, many communities almost certainly understood water travel far better than the surviving record shows. The absence of boats in a museum drawer is not the absence of boats in life. The emotional geography of drowning is harder still to recover. A coast is not just a resource zone. It is a remembered world of paths, names, stories, dangers, and dead. If a burial ground is threatened by water, do people move the bones, abandon them, mark a new place, or return until return becomes impossible? If a sacred rock becomes an island, does it grow more powerful or become unreachable? If an ancestral camp is swallowed, does memory sharpen or fade? These questions cannot be answered with confidence. But they matter because human adaptation is never only practical. People do not simply relocate like animals following habitat. They carry meanings, obligations, grief, and identity. By the early Holocene, the pace of sea level rise continues to reshape the world. Some coastlines stabilize only much later. The modern outlines of continents emerge gradually, and even then they remain subject to storms, subsidence, erosion, and local change. What appears fixed on a schoolroom map is a temporary arrangement. The post-Ice Age people who watched the sea climb lived closer to this truth than most later civilizations. They knew in ways modern societies are relearning uneasily that coastlines move. Somewhere on a low shore, a family returns to a place where fires once burned above the tide. The old hearth is gone. The bank has collapsed. Shells lie scattered where waves have cut into the camp. Farther inland, there is a new place to settle, but it is not the same. The view is different. The wind carries a different smell. The path to fresh water is longer. Someone old enough to remember the former shore stands quietly for a while, measuring loss without numbers. Then the group turns away, because hunger leaves little room for mourning. That scene, repeated in countless forms across thousands of coasts, may be one of the central, human experiences of the Ice Age's end. Not one flood, but many encroachments. Not one drowned city, but thousands of drowned camps. Not a single apocalypse, but a slow retreat from places once believed permanent. The sea rises, and the human world moves inland, carrying fragments of memory away from the water's edge. Beneath the waves, the old ground darkens, settles, and disappears from speech. As the ice retreats and the seas climb, another transformation moves across the land more quietly, rooted in soil, pollen, shade, and hunger. Forests begin to return, in places that had once been open steppe or tundra. Young trees rise in scattered patches, then thicken into woodland. Birch appears first in many northern landscapes, pale trunks against dark ground, followed by pine, hazel, oak, elm, lime, and other species where climate allows.
The change is gradual in some regions and sudden in others, but its meaning is enormous.
A person who grows up in open country may live long enough to see familiar distances close in. The Ice Age world had rewarded wide vision. On open steppe, hunters could watch herds from far off, follow tracks across exposed ground, and move through landscapes where large animals gathered in visible numbers. Forest changes all of that. Trees create cover. They break sight lines. They scatter animals into smaller groups. They change the sound of movement, the direction of wind, the quality of snow, the plants underfoot, and the dangers hidden nearby. Hunting in woodland requires different patience, different weapons, and different knowledge. A spear meant for a large open country animal is not always the best tool in dense trees. Smaller projectiles, traps, bows, dogs in some regions, and careful ambush become more important. The spread of forest does not mean the land becomes empty. In many places, it becomes rich in a different way. Deer, wild boar, aurochs, elk, birds, squirrels, fish, and countless smaller creatures thrive in woodland. Rivers and wetlands, hazelnuts, acorns, berries, roots, greens, fungi, and seeds offer seasonal food. Wood provides fuel, handles, shelters, digging sticks, boats, containers, and traps. Bark, fiber, resin, and leaves become part of daily technology. Yet this richness is less concentrated than a migrating herd and often harder to harvest. Quickly. It asks people to know many small calendars instead of one great animal calendar. One surprising detail from early Holocene Europe is the importance of hazelnuts. Charred hazelnut shells appear at many Mesolithic sites, sometimes in large quantities, suggesting organized gathering, roasting, and possibly storage. A hazelnut is not dramatic like a mammoth, but it is dense with fat and energy, easy to transport, and available in seasonal abundance. It represents a different kind of survival, not the glory of bringing down a giant, but the patient intelligence of returning at the right time, processing carefully, and keeping enough for later. In the new forests, hunger is solved less by one spectacular kill, and more by 1,000 precise acts. This broadening of diet is often called a broad-spectrum adaptation, though the phrase sounds too dry for what it means. It means people are learning to live from a wider range of resources as old systems become less reliable. Fish traps, nets, basketry, grinding stones, digging tools, and storage pits may matter as much as hunting weapons. Much of this technology is made from organic material and vanishes easily, which means the archaeological record often understates the skill involved. Stone points survive, nets decay. A museum may show the blade and lose the woven world that made it useful. In wetlands, the change is especially powerful. Reed beds spread along lakes and marshes. Waterfowl gather in huge seasonal numbers. Fish move through shallows. Beavers alter waterways. Freshwater mussels and plants offer additional food. Wetlands can support repeated occupation because they gather resources from land and water together. But they can also be difficult, insect-heavy, unstable, and dangerous. A marsh is not a simple paradise. It can feed people well and drown them easily. It preserves footprints in mud and erases paths in reeds. It rewards those who know it intimately. As forests and wetlands expand, people may become more attached to particular places, not everywhere and not all at once. Many groups remain mobile, and movement continues to be a strength. But in resource-rich zones, especially near rivers, lakes, coasts, and woodland edges, returning again and again becomes attractive. The land offers different foods at different times of year. Fish runs, nut harvests, bird migrations, deer movements, and plant ripening can create a seasonal rhythm that pulls people back. Over time, repeated return can become something close to belonging. This is where the end of the Ice Age begins to change social life in subtle ways.
If people depend on many resources in one region, they must know that region deeply. They may defend access to it more strongly. They may bury their dead there, not only out of grief, but because the dead anchor the living to land. Cemeteries become possible, where groups return often enough to maintain a relationship with a place. Ornaments, tool styles, and rituals may mark identity more sharply as neighboring groups occupy increasingly defined territories. Scholars still debate how widespread and early these changes were, but the direction is visible in many regions. Place begins to matter differently. The new hunger is therefore not only hunger for food, it is hunger for predictability. In the old open landscapes, predictability may have come from migratory herds and long-distance movement. In the new mosaic, it may come from knowing many resources within a smaller or more repeatedly used territory. This can encourage experimentation with storage and management. A patch of useful plants near camp is noticed. A stand of nut trees is protected. Burning may keep certain areas open. Seeds may fall near disturbed soil and grow better where people return. None of this is farming yet, but it is no longer a purely hands-off relationship with nature either. The forest also changes imagination. Large open country animals that once dominated art and memory become rarer or vanish. Woodland animals enter daily life more often. Trees themselves become structures of thought, sources of fuel, shelter, tools, shade, danger, and perhaps spirit. The record is too fragmentary to reconstruct belief with confidence, especially because wood, bark, and fiber rarely survive. But it would be strange if such a profound change in surroundings did not alter stories and rituals. A person raised under trees hears the world differently from a person raised under open wind. There are costs. Forested landscapes can make travel slower. They hide enemies and predators. They reduce the huge grazing grounds needed by some animals. They may isolate groups that once saw each other more often across open country. They can also bring new disease ecologies, with more insects, standing water, and closer contact with certain animals. Rot becomes a problem for stored food and wooden structures. Smoke behaves differently under a damp canopy. A warmer, greener world is not automatically a kinder one. Still, humans adapt with remarkable speed. They make axes and adzes for working wood. They refine fishing technologies. They use dogs where present as companions, hunters, guards, and perhaps spiritual partners. They build more substantial shelters in some places and lighter seasonal camps in others. They exploit shorelines, forests, rivers, and uplands as connected parts of one annual cycle. The world is no longer the mammoth steppe, but it is full of possibility for those who learn its new grammar. What survives in the record suggests that this period is not a decline after the grandeur of Ice Age cave art, even though it has sometimes been treated that way. It is a different form of complexity. A carved bone harpoon, a fish trap, a carefully shaped microlith, a cemetery beside a river, a pile of roasted hazelnut shells, a canoe preserved in wet sediment, or a wooden trackway across marshland can reveal intelligence as deep as any painted cave. It is simply intelligence tuned to a changed world. By now, the end of the Ice Age has become more than a climate transition. It has become a new education. Humans must learn forests, wetlands, rising coasts, smaller prey, seasonal plants, and the social weight of staying closer to rich places. The old hunger for meat remains, but it is joined by hunger for fish, nuts, roots, seeds, shellfish, birds, and stored time itself. The land offers more kinds of food, but fewer guarantees. Somewhere in a young forest, a hunter pauses where an open view used to be. Trees crowd the slope. Tracks vanish into leaf litter. The old herd is gone, or perhaps only farther away than before. Nearby, someone cracks roasted hazelnuts beside a fire. Children carry fish from a trap woven of branches. Smoke lifts into the canopy, instead of disappearing across the plain. The world has narrowed in sight, but widened in detail. Survival now belongs to those who can read not only the horizon, but the small signs at their feet. The first seeds of a new life are not planted in a neat field, by people who have suddenly decided to invent farming. They appear in a slower, stranger borderland, where gathering, tending, returning, storing, burning, clearing, and watching begin to overlap. For thousands of years, humans have known plants with extraordinary precision. They know which seeds can be eaten, which roots must be processed, which fruits ripen after rain, which grasses return after fire, which bitter foods become safe after soaking, pounding, roasting, or leaching. Agriculture does not begin because people discover that plants grow. Everyone already knows that it begins when old relationships with plants become more intense, more deliberate, and more necessary. At the end of the Ice Age, this intensification happens unevenly across the world. In Southwest Asia, wild wheat, barley, rye, lentils, peas, and other useful plants grow across varied landscapes of hills, valleys, woodland, steppe, and river corridors. In some regions, people harvest wild cereals long before they domesticate them. They cut grasses with stone blades, carry seeds back to camp, grind them, roast them, store them, and return to the same productive stands year after year. Microscopic wear on tools, starch grains, charred seeds, grinding stones, and storage features all help reveal this changing relationship. What survives in the record suggests not one brilliant invention, but a long conversation between human habit and plant biology. Wild cereals are powerful foods, but they are not effortless gifts. They ripen seasonally. They must be gathered at the right moment. Their seeds fall easily from the stalk when mature, which is useful for a wild plant, but inconvenient for harvesters. Over time, when humans collect and sow seeds, even unintentionally at first, they may favor plants whose seeds stay attached longer, whose grains are larger, or whose growth fits disturbed ground around camps. Domestication is visible archaeologically when plant traits begin to change, but the human behaviors that lead there may begin earlier and remain difficult to see. The evidence remains incomplete because the first steps are often small enough to disappear. The Younger Dryas may play a role in this story, especially in the Near East, but it is not a simple trigger. Cooler, drier conditions may have reduced the availability of some wild resources and placed stress on communities that had become more settled or more reliant on local plant foods. Some scholars argue that this pressure encouraged cultivation. Others caution that agriculture emerges after the Younger Dryas, during renewed warming, and that social, ecological, and demographic factors matter just as much as climate stress. No single explanation fully accounts for the transition. Hunger alone does not create farming. Knowledge alone does not create farming. A good climate alone does not create farming. The shift requires people, plants, places, risk, memory, and time. In some communities, staying longer near reliable resources changes everything. A camp occupied for weeks becomes a place occupied for months. A seasonal return becomes a stronger attachment. Storage pits are dug. Grinding stones grow heavy enough that carrying them far makes less sense. Houses or semi-permanent structures appear. Burials nearby deepen the bond between people and place. Once a group invests labor into a location, leaving becomes more complicated. Stored food must be protected. Structures must be maintained. Neighbors must be negotiated with. A rich place can support life, but it can also hold people in place. This is one of the great paradoxes of the agricultural transition. Farming will eventually allow larger populations, villages, cities, states, and written histories. But it may not begin as an obvious improvement. Early cultivation can be hard work. Fields must be cleared, seeds gathered or sown, weeds controlled, harvests processed, stores defended. Diets may narrow in some places. Dependence on a few crops can increase risk if rains fail or pests strike. Skeletal evidence from later farming communities often shows signs of stress, disease, and labor strain. The path toward agriculture is not a simple march toward comfort. It is a wager on predictability. And like all wagers, it carries danger. Yet the wager makes sense in certain landscapes.
If wild cereals grow densely enough, if people already gather them intensively, if population pressure or territorial boundaries make constant movement harder, if climate instability makes storage valuable, and if social life rewards feasting, exchange, or control of surplus, then plant management can deepen gradually. A field is not born from an idea alone. It is born from repeated returns to a patch of ground and the realization, perhaps never stated, in a single moment, that the patch can be made to answer human needs more reliably. The change is not limited to Southwest Asia, though that region becomes one of the earliest and most influential centers of domestication. In China, millet and rice follow their own long paths toward cultivation in different ecological zones. In New Guinea, people manage and cultivate plants such as taro and bananas in highland environments. In the Americas, squash, maize, beans, potatoes, and other crops will follow complex domestication histories, some beginning later, but rooted in equally deep plant knowledge. In Africa, sorghum, pearl millet, yams, and other crops emerge from distinct regional traditions. Agriculture is not a single invention, exported from one brilliant center to a passive world. It is a set of transformations that different peoples make under different conditions. Around the immediate end of the Ice Age, however, the Near Eastern story stands out because it lies close to the threshold between late foraging and early farming.
Natufian communities had already shown that people could live in more settled ways while still relying on wild resources. After the Younger Dryas, pre-pottery Neolithic communities begin moving more clearly toward cultivation, village life, and eventually domesticated plants and animals. This transition is slow and layered. Early villages may still hunt. Early cultivators may still gather wild foods. The boundary between hunter-gatherer and farmer is blurred for long periods. Modern categories are tidy because they are made after the fact. Ancient life was not tidy. One surprising detail is that bread-like foods may predate farming.
Archaeological evidence from some late Pleistocene contexts suggests that people processed wild grains into flour and possibly made flatbread-like products before agriculture was fully established. This turns the familiar story upside down. People did not necessarily start farming and then invent bread. In some places they may have desired grain foods first, then gradually intensified the systems that produce them. Taste, tradition, feasting, and social meaning may have mattered alongside calories. A food can become important not only because it prevents starvation, but because it gathers people together. Feasting may be one of the hidden engines of change in societies without formal states.
Gatherings can build alliances, settle tensions, arrange marriages, honor the dead, mark seasons, and display generosity or status. To host a feast, people need surplus or reliable access to concentrated resources. Wild cereals, stored nuts, fish, meat, and later cultivated plants can all support such events. The desire to feed many people at once may encourage storage and production beyond immediate household need. Scholars still debate how central feasting was in the origins of agriculture, but it offers a powerful reminder that humans do not live by calories alone. They live by reputation, obligation, memory, and ritual. As plants become more central, animals also enter a changing relationship with humans. Dogs are already companions and partners long before agriculture.
Later, goats, sheep, cattle, pigs, and other animals will be domesticated in different settings, not simply captured in a single act, but drawn into human worlds through hunting, herd management, protection, selection, and proximity. At first, the line between wild and managed can be thin. People may follow herds, control access to certain animals, protect young, or hunt selectively. Over generations, animal bodies change under human influence. But this too is not immediate. Domestication is a process, not a moment. The shift toward cultivation also changes time. Hunter-gatherers certainly plan ahead, sometimes with extraordinary sophistication. But cultivation binds certain tasks to a seasonal schedule that cannot be ignored.
There is a time to prepare ground, a time to sow, a time to weed, a time to harvest, a time to process, a time to store. Missing the right moment can have consequences months later. The year becomes structured around plants as much as animals. Labor becomes more predictable and perhaps more demanding. Children grow up learning not only where food is found, but how food is coaxed, guarded, and transformed. With this comes a new vulnerability. A mobile group can leave a failing place more easily. A settled group with stores, structures, fields, and graves cannot move without losing investment. Attachment brings security and risk together. A village can hold food through winter, but it can also become a target. A field can feed many, but it can fail. A storehouse can preserve life, but it can rot or be raided. The new life emerging from seeds is not simply progress. It is a different bargain with uncertainty. At the end of the Ice Age, this bargain is still young. Most humans on Earth are not farmers. Many will remain foragers, fishers, hunters, herders, or mixed economies for thousands of years. Some will choose not to farm even when they know farming exists, because their own landscapes offer better alternatives, or because the costs are too high. Farming spreads not because it is always superior, but because in certain conditions it supports population growth, surplus, territorial life, and eventually institutions that expand their reach. But in its earliest form, the seed of this new life is modest. A handful of grain near a hearth.
A grinding stone too heavy to carry far. A storage pit lined carefully against damp. A stand of wild plants visited with unusual attention. A child learning which seeds are worth keeping. A group returning not only because food is there, but because food might be made to be there again. The Ice Age world is ending, and as the great animals vanish from many landscapes and coastlines move inland, another kind of power is being discovered in the small, dry body of a seed. No one yet sees the full consequence. No one sees cities, kings, taxes, armies, writing, plagues, markets, and temples hidden inside the first managed fields. The people at the threshold see only the immediate promise and danger of a more dependable food. They are not abandoning the wild. They are pulling parts of the wild closer, slowly enough that the change may feel at first like memory, habit, and common sense. But the direction has shifted. Human survival is beginning to root itself in place. Long before the first cities rise, before walls, kings, writing, and fields arranged into the hard geometry of later civilization, people begin making places that are more than camps. They're not yet towns in the familiar sense, and they're not simple villages, if by village one imagines a quiet cluster of permanent houses surrounded by farmland. They are something more uncertain and more interesting, repeated places, remembered places, places where food, labor, ritual, storage, burial, and identity begin to gather. At the end of the Ice Age, the human world does not suddenly settle down. It thickens around certain points on the landscape. A temporary camp leaves a light trace, a few hearths, broken tools, animal bones, perhaps post holes if shelter was built well enough to mark the ground. A place used again and again leaves a deeper signature. Ash accumulates. Floors are repaired. Stones are carried in and not carried away. Burials appear. Storage pits cut into earth. Refuse gathers. Structures are rebuilt over earlier structures. People return not because movement has ended, but because this place has become reliable, meaningful, or both. Over time, the difference between returning to a place and living in a place begins to blur. This shift is visible in parts of Southwest Asia before full agriculture, especially among Natufian communities. Some Natufian sites contain stone-built structures, groundstone tools, burials, ornaments, and evidence of intensive use of wild plants and animals.
These people are still hunter-gatherers, but not in the old stereotype of small bands constantly moving through empty wilderness. Some live for long periods in favorable locations. Some bury their dead close to habitation areas. Some use heavy tools that imply repeated occupation. Their world is still wild, but their relationship to place has changed. At a site such as Ain Malaha in the Levant, round or oval structures suggest substantial investment in architecture before domesticated farming is fully established. Stone foundations, prepared floors, and repeated occupation hint at communities organized around more stable locations. At other Natufian sites, burials include ornaments made from shells, bones, and teeth, sometimes showing long-distance connections. Dogs appear in some burial contexts, including one famous case where a human was buried with a puppy or young dog, a detail that feels startlingly intimate across more than 12,000 years. The evidence remains incomplete, but it suggests emotional and social worlds far richer than survival alone. Permanent or semi-permanent places change the pressure inside human society. When people move often, possessions must remain portable. Heavy objects are a burden. Refuse can be left behind. Social tensions can sometimes be solved by distance. But when people stay longer, everything accumulates. Food, tools, waste, obligations, restus, memory, envy, grief, and dispute. A house is shelter, but it is also a claim. A storage pit is security, but also temptation. A burial is mourning, but also an anchor. Settlement gives people roots, and roots hold firmly in both good soil and bad. One of the most important consequences is storage. A settled or semi-settled community can gather seasonal abundance and keep it. Wild cereals, nuts, dried meat, fish, and other foods can be stored against lean months. This reduces some risks, but creates others. Stored food must be protected from damp, insects, rodents, thieves, and internal disagreement. It may be shared according to kinship, status, need, ritual, or power. A surplus can feed children and elders. It can also allow some people to command labor or generosity from others. The first stored foods do not automatically create inequality, but they make new forms of inequality possible. Architecture also changes relationships. A shelter built for a few nights is one thing. A structure that takes serious effort to construct and repair is another. It implies planning, cooperation, and expectation of return. In some early communities, houses are round or semi-subterranean, partly dug into the ground and built with stone, wood, brush, or mud. Later, rectangular architecture becomes more common in some regions, a change with social consequences of its own. Rectangular buildings can be expanded, joined, divided, and arranged in denser settlements more easily than circular ones. This may sound like a minor architectural detail, but the shape of a house can shape the life inside it. The first permanent places are not only practical, they are also symbolic. People bury the dead beneath floors, near houses, or in cemeteries. Skulls may be treated in special ways in some later Neolithic contexts, removed, plastered, painted, or kept. These practices are difficult to interpret with certainty, and scholars still debate whether they reflect ancestor veneration, household identity, ritual power, grief, or something else entirely. But they show that place and memory are becoming tightly bound. The dead are no longer only left behind on a moving path. In some communities, they remain near the living, part of the architecture of belonging. The presence of the dead can make leaving harder. A mobile group can carry stories of ancestors across wide territories, but a settlement with buried ancestors creates a different claim. This is where they are. This ground matters because bodies, memories, and obligations are here. Such attachment may strengthen community identity, but it can also sharpen boundaries. If several groups want access to the same water, grain stands, hunting grounds, or ritual center, the question of who belongs becomes more urgent. Territory begins to acquire a new emotional density. There are also changes in labor. In a mobile foraging life, labor is often intense but flexible.
shaped by season and opportunity.
In more settled life, new tasks appear and repeat, maintaining structures, cleaning living areas, protecting stores, processing large quantities of grain or nuts, repairing walls, managing waste, caring for nearby resources, and negotiating the friction of more people living close together. The grinding of seeds, in particular, can be physically demanding. Skeletal remains from later agricultural and semi-agricultural communities often show strain from repetitive work, though patterns vary by region and gender. The new life may be more secure in some ways, but it is not necessarily easier on the body. Crowding is another cost. When people live together longer, refuse builds up. Food scraps attract animals. Human waste becomes a problem. Smoke accumulates in enclosed spaces. Parasites find opportunities. The closeness that makes cooperation easier also makes sickness easier. Before full farming, these pressures may already be emerging in some more settled communities. Later, with domesticated animals and larger villages, they will intensify. The first permanent places carry the seeds not only of civilization, but of its discomforts. Yet people continue to gather and settle because these places offer powerful advantages. They may sit near reliable springs, lakes, rivers, or stands of wild cereals. They may control access to stone, salt, fish, or seasonal migrations. They may serve as meeting points, where scattered groups come together to exchange goods, arrange marriages, perform rituals, and renew alliances. A place can be important, even if it is not occupied year-round. Some sites may function as aggregation centers, drawing people at certain seasons and dispersing them afterward. The line between village, camp, shrine, market, and meeting ground is not yet clear. This ambiguity is crucial. The earliest permanent or repeated places are not simply early versions of later towns. They belong to their own world. A settlement may be occupied seasonally, then abandoned, then reoccupied. A ritual site may draw labor from people who do not live there permanently. A cluster of houses may depend more on hunting and gathering than on cultivation. A community may plant some crops while still relying heavily on wild foods. The modern need to classify can make ancient life seem more rigid than it was. The first permanent places also alter time. A mobile camp is tied to the rhythm of movement. A settlement is tied to the rhythm of return. People begin to inherit not only tools and stories, but built environments. A child may grow up with the remains of older floors beneath their feet. A repaired wall may contain stones set by grandparents. A storage pit may be dug where another pit once stood. The past becomes physically layered in the ground. Archaeologists later call these layers stratigraphy, but for the people living there, they are simply the thickness of home. One surprising consequence of repeated settlement is the creation of tells in some regions, mounds formed by generations of building, occupation, collapse, and rebuilding in the same place. These great mounded sites become more prominent later, in the Neolithic and beyond. But the principle begins with the simple act of returning to the same ground. Human life starts to leave vertical histories. The land rises slightly under the weight of memory, refuse, plaster, ash, and rebuilding. A place becomes taller because people cannot stop coming back. This new attachment to place does not erase mobility. People still hunt, gather, visit, trade, marry out, travel for stone, follow herds, and move seasonally. But now there is often a center of gravity, a home base, a ritual center, a cemetery, a reliable settlement near food and water. From such centers, the world is organized differently. The landscape becomes not only a route, but a territory around a fixed point. That change may seem subtle, yet it is one of the foundations on which later civilization will stand. At the same time, the evidence warns against assuming that settlement always leads directly to farming, and farming always leads directly to cities. There are settled hunter-gatherers in rich environments. There are mobile farmers and herders. There are communities that experiment and then retreat from cultivation. There are places where agriculture spreads, but cities do not appear for millennia. Human history is not a ladder. It is a branching river, with channels that split, dry, reconnect, and disappear under sediment. Still, around the end of the Ice Age, something irreversible begins in certain regions. Not irreversible for every group, but irreversible for the long human story.
People discover, or more precisely deepen, the power of staying. Staying allows storage, memory, architecture, ritual concentration, and population growth. It also brings waste, disease, tension, labor, and vulnerability. The first permanent places are therefore not peaceful beginnings outside history. They are already complicated. Imagine one of these early settlements, near a spring and a stand of wild grain. The houses are low, rounded, partly sunk into the earth. Smoke rises from hearths. Grinding stones rest where they are used because they're too heavy to move casually. Shell beads from a distant coast lie on a body placed carefully beneath the ground. Dogs linger near refuse. Children run between structures built before they were born.
Beyond the settlement, people still know the wild paths, the hunting grounds, the seasonal plants, and the dangers beyond the familiar slope. They are not yet villagers in the later sense. They are something older and more uncertain, people learning what it means for life to gather in one place and remain. On a limestone ridge in southeastern Anatolia, long after the deepest cold has passed but before the full world of farming has settled into place, peeping carved stone, as if the old categories of prehistory are not enough to contain them. They raise pillars taller than a person, shape them into abstract human forms, and cover them with animals. Foxes, snakes, boars, birds, aurochs, scorpions, and creatures that seem to move between the real and the symbolic.
The site is now known as Göbekli Tepe, and it stands near the edge of the Ice Age's end, like a challenge placed in the ground. For a long time, many people assumed that monumental building came after agriculture, after settled villages, after surplus food, after social hierarchy had grown strong enough to command labor. First farming, then villages, then temples. Göbekli Tepe complicates that tidy sequence. Its earliest major structures date to the pre-pottery Neolithic, a time when people in the region are moving toward cultivation and more settled life, but are not yet living in the later world of pottery, mature farming, and domesticated village economies. The builders are not primitive wanderers suddenly acting beyond their capacity.
They are skilled, organized communities, capable of planning, quarrying, carving, transporting, arranging, and returning to a place that clearly matters. The site does not prove that religion invented agriculture in a simple sense, though that idea has sometimes been popularized too strongly. It does show that belief, gathering, ritual, cooperation, and social ambition may have played a deeper role in the transition than older models allowed. People may have come together at special places before the practical machinery of farming was fully established. They may have needed feasts, ceremonies, alliances, and shared symbols as much as grain. Or perhaps those gatherings increased the demand for food, encouraging more intensive plant use nearby. Scholars still debate the relationship.
What survives in the record suggests feedback, not a single cause. People gather, food needs rise, plants are managed more closely, settlements grow, rituals intensify, and the boundary between wild and cultivated shifts again. Göbekli Tepe is not a city. It is not a lost capital. It is not evidence for a vanished advanced civilization. The most careful interpretation is stranger and more grounded. It is a monumental ritual landscape, built by people whose world is changing quickly, people who still hunt and gather, while also living amid the early currents that will lead toward farming. The enclosures with their T-shaped pillars and animal reliefs may have hosted ceremonies, feasts, initiations, commemorations, or gatherings whose meanings are now unreachable. No written explanation survives. The stones speak, but not in a language that can be translated. The animals carved there are especially important. Many are dangerous, elusive, or powerful. They're not simply a menu of daily meals. Foxes with long bodies, snakes curling across stone,
boars bristling with threat, birds with strange authority, and wild cattle with massive force suggest a symbolic world still deeply tied to wild animals. This matters because Göbekli Tepe rises during the long transition away from the Ice Age, hunting world, and toward more settled landscapes. The wild has not disappeared. It remains central to imagination, even as human life begins tightening around places, stores, and managed plants.
The carvings may preserve a final intensity of the wild at the very moment when humans are beginning to pull parts of nature under closer control. There is a powerful contrast between the site's monumentality and the absence of many things expected from later civilization. No pottery in the earliest levels, no writing, no metal, no king's inscriptions, no scenes of armies or tribute. Instead, there is stone, labor, animal imagery, and the repeated shaping of enclosed spaces. This should make the achievement feel more impressive, not less. It reveals social complexity before the usual markers of civilization appear. People do not need cities to organize large projects.
They need shared purpose, skilled knowledge, leadership or coordination of some kind, and reasons strong enough to bring labor together. Those reasons may have included feasting. Archaeologists have found evidence in the broader region for large-scale food processing and consumption at early communal sites. And Göbekli Tepe itself has been discussed in connection with gatherings that required feeding many people. Feasts are not trivial. They create obligations, display generosity, build alliances, settle rivalries, attract partners, honor the dead, or renew relationships between groups. To host a feast, people need food beyond immediate daily use. That need can encourage hunting, coordination, grain gathering, brewing experiments, storage, and eventually cultivation.
The evidence remains incomplete, but the idea is compelling because it places human desire, display, and ritual at the center of economic change. Another striking feature is that some Göbekli enclosures were deliberately filled in. This was not simply abandonment by collapse. Large amounts of material, including stone debris, animal bones, and sediment, were used to bury spaces that had once been important. Why do that? Scholars still debate the answer. Perhaps the filling marked ritual closure. Perhaps rebuilding and burial were part of the site's life cycle. Perhaps later, people changed how they used the place. Whatever the reason, deliberate burial suggests that the meaning of the site included not only construction, but also transformation.
A sacred or special place could be made, used, altered, and closed. Göbekli Tepe is also not alone. Nearby sites such as Karahan Tepe and others in the broader Taş Tepeler region suggest a wider landscape of early monumental and ritual activity. This matters because a single extraordinary site can be mistaken for an anomaly. But a cluster suggests a regional pattern. People in this part of the world were experimenting not only with food and settlement, but with architecture at a scale that gathered communities into shared symbolic spaces. The end of the Ice Age did not merely push people into farming through hunger. It opened a world in which cooperation itself could become monumental. And yet, caution is necessary. It is tempting to turn Göbekli Tepe into a grand key that unlocks all human history. It does not. It is one site or one regional phenomenon in a much larger global transition. It tells us something profound about Southwest Asia, about the early Neolithic, about ritual before full farming, and about the complexity of hunter-gatherer or transitional communities. It does not explain the origins of agriculture everywhere. It does not prove a forgotten high civilization. It does not justify every popular mystery attached to it. The real mystery is not that impossible people built it. The real mystery is that possible people were far more socially and symbolically ambitious than older assumptions allowed. The site also changes how we think about the end of the Ice Age psychologically. Climate change, extinction, and sea level rise are not only pressures to be endured. They may also generate new forms of gathering, meaning, and authority. When landscapes shift and old certainties weaken, people may respond by intensifying ritual life. A special place can hold a community together. When the wider world feels unstable, animals carved in stone can preserve relationships with powers that are disappearing, changing, or becoming more dangerous. Monumentality can turn uncertainty into order, or at least into a shared experience. The labor itself would have mattered. Quarrying a pillar, shaping it, dragging it, raising it, and arranging it inside an enclosure requires coordination. People must be fed. Work must be timed. Knowledge must be transmitted. Someone must know how stone breaks, how much weight can be moved, how a pillar can stand even without formal states. Such work creates social bonds and social distinctions. Some people may become experts, ritual leaders, organizers, carvers, or keepers of knowledge. Inequality in the later sense may not yet dominate, but difference in role and prestige likely grows around such places. Göbekli Tepe therefore sits at a crossing point. Behind it are millennia of mobile foragers, ice age hunters, cave artists, drowned landscapes, and vanished giants. Around it are communities increasingly tied to place, wild cereals, storage, feasting, and symbolic gathering. Ahead lie domesticated plants and animals, larger villages, heavier labor, disease, inequality, and eventually the vast structures of civilization. The site does not belong wholly to one side or the other. It is a threshold made of stone. Imagine approaching it in its own time. The hill rises above a landscape not identical to today's dry terrain, with wild resources still present in seasonal patterns. People come from different groups, perhaps speaking related dialects, carrying food, skins, tools, ornaments, memories, and obligations. The pillars stand within enclosed spaces, their animal forms catching the changing light. There is no writing to explain them, no priestly text, no royal boast. There is only the gathering itself. The carved stone, the smell of food, the pressure of many bodies. The knowledge that this place matters because people have made it matter. At the end of the Ice Age, survival is no longer only a matter of following herds or reading plants. It is also a matter of binding people together at scales larger than a single camp. Göbekli Tepe shows one way that could happen, in stone, animal, labor, and ritual. It preserves the intensity of a world becoming new, without yet knowing what it will become. The ice is gone from the ridge, but the old wild still stares from the pillars, and around those stones, humans begin to rehearse one of their most powerful and dangerous abilities, the ability to gather around shared meanings, build something larger than daily need, and let that larger thing change the course of life. The new settled life carries a cost that is easy to miss at first, because it begins in small, ordinary closeness. More people sleep near one another. Food scraps collect near houses. Dogs linger around refuse. Rodents find stores. Insects breed in damp places. Smoke fills shelters. Waste becomes harder to leave behind. Water sources are used again and again. A camp that might once have been abandoned after a season now becomes a place where yesterday's, as good as dirt, remains under tomorrow's feet. The first permanent places are not only beginnings of community, they are beginnings of crowding. This does not mean earlier hunter-gatherers lived without disease. Humans have always carried infections, parasites, injuries, tooth problems, hunger stress, and the dangers of childbirth. Ice Age people knew sickness long before villages, but mobility can break certain chains of infection. When a small group moves away, waste, fleas, contaminated ground, and some accumulated hazards are left behind. When people live in one place longer, those hazards remain close. Settlement changes the ecology of disease. It gives germs, parasites, and pests more opportunities to persist. The relationship between humans and animals also begins changing in ways that will later become transformative. Dogs are already close companions, but as people move toward managing goats, sheep, pigs, cattle, and other animals, The boundary between human space and animal space narrows. At first, this process is uneven and gradual. People hunt wild herds, manage access, protect certain animals, or keep young ones near settlements. Over generations, domesticated animals become part of daily life. They provide meat, milk later in some traditions, hides, bone, labor, dung, and wealth. But they also bring new risks. Close contact with animals creates opportunities for pathogens to cross species boundaries. Though many of the major crowd diseases of later history require much larger populations than early villages could sustain, this distinction matters. It would be wrong to imagine the first small settlements instantly suffering from the great epidemic diseases known from historical civilizations. Measles, smallpox-like diseases, influenza-like outbreaks, and other major crowd infections depend on dense, connected populations that develop much later. But the foundations are being laid. More people together, more animals nearby, more waste, more stored food, more pests, more repeated contact between communities. These create a new disease landscape. The evidence remains incomplete, because pathogens rarely preserve clearly. But skeletal stress, parasite remains, ancient DNA, and settlement conditions all suggest that the move toward denser life brought biological consequences. Food itself becomes a source of risk. Stored grain can save a community, but it can also attract rodents and insects. Damp stores can rot. Mold can poison. A failed store can turn security into disaster. If people become more dependent on a narrower range of foods, nutrition may suffer, even when calories increase. Later farming populations in many regions show signs of dental cavities, enamel defects, anemia, and skeletal stress. Though patterns vary, grain-based diets can be filling, but they may lack the diversity of earlier mixed foraging diets. The new life offers quantity and predictability, but not always health. Labor leaves marks as well. Grinding grain hour after hour reshapes muscles and joints. Digging, carrying, harvesting, building, and processing food produce repetitive strain. Knees, backs, shoulders, and teeth become tools. In many early societies, teeth are used for gripping fibers, softening hides, or working materials, leaving wear that tells of vanished crafts. The body becomes an archive of daily work. What survives in bones is only the hardest evidence of a much wider truth. Settlement and food production ask people to spend more time doing repeated tasks that the old, mobile life did not require. In the same way, crowding also changes conflict. When groups are mobile, tension can sometimes be solved by separation. When houses, fields, stores, and ancestors tie people to place, walking away becomes harder. Disputes over stored food, access to water, hunting territories, plant stands, ritual status, marriage, and inheritance can become sharper. Evidence for violence in early settled and transitional communities is patchy and regionally varied, and it should not be exaggerated into a simple story of inevitable warfare. But the potential for conflict grows when resources are fixed and defensible. A storage pit can feed a family through winter. It can also become something worth stealing. Inequality may begin quietly, not with crowns or palaces, but with differences in access, obligation, and prestige. Some households may store more. Some people may control ritual knowledge. Some may organize labor for building or feasting. Some may have stronger kin networks or better land. Grave goods in certain early burials suggest distinctions, though interpreting status from burial is never simple. A rich burial may reflect affection, role, age, ritual meaning, or social rank. Scholars still debate how early durable inequality appears in different regions. But settlement, storage, and surplus make inequality easier to preserve across time. At the same time, cooperation becomes more necessary than ever. A village cannot function as a crowd of isolated individuals. People must share labor, maintain relationships, care for children, support the injured, negotiate disputes, and coordinate seasonal tasks. Feasting, ritual, and collective building may help hold communities together under pressure. The same forces that create inequality can also create generosity. A surplus can be hoarded, but it can also be shared. A ritual leader can dominate, but also mediate. A settlement is a machine for producing both solidarity and tension. The hidden cost of settlement is therefore not one thing. It is a bundle of trade-offs. More food can mean more people, but more people can mean more disease. Storage can mean security, but also theft and rot. Houses can mean shelter, but also waste and smoke. Animals can mean wealth, but also infection. Ancestral ground can mean belonging, but also conflict over who belongs most. The first permanent places are not mistakes. They are solutions that create new problems. This is why the end of the Ice Age is so consequential. Climate change does not simply make farming possible by warming the world. It pushes humans into new relationships with place, food, animals, and one another. Those relationships generate pressures that earlier societies did not experience in the same way. Once people begin living closer together and investing more heavily in particular landscapes, they enter a path where growth can feed on itself. More food supports more children. More children require more food. More labor can expand production. Expanded production supports still more people. The cycle is powerful, but it tightens the trap. No one at the threshold sees the trap in full. A mother grinding seeds sees food for her child. A hunter bringing meat back to a settlement sees relief. A builder repairing a wall sees shelter. A ritual gathering sees belonging, memory, and obligation. The larger pattern only becomes visible later. When villages grow, animals are penned, fields spread, and human bodies begin carrying the biological marks of a new age. What begins as adaptation becomes inheritance. Somewhere in an early settlement, smoke hangs low beneath a roof. A child coughs. Grain dries near a hearth. Dogs nose through discarded bones. Outside, a storage pit is covered carefully against damp and pests. Beyond the houses, wild land still begins almost immediately. People still hunt, gather, fish, and watch the weather with old attention. But the center of life has shifted inward, toward the clustered shelter, the shared fire, the stored food, the buried dead. The world is becoming safer in some ways and more dangerous in others. Civilization's earliest shadow is not conquest or empire. It is closeness. After the long interruption of the Younger Dryas, the warmth returns with a force that changes the future. Around 11,700 years ago, the Holocene begins, not as a word spoken by anyone alive at the time, but as a new pattern written into ice, pollen, oceans, forests, and human life. The cold world does not vanish everywhere in a single breath, yet the direction becomes clearer. Ice sheets retreat farther, forests spread more widely, sea levels continue climbing, rivers settle into new courses, then change again. The great open landscapes of the Pleistocene shrink, and the planet enters a warmer, relatively more stable climate interval in which nearly all later recorded history will unfold. This stability is easy to misunderstand. The Holocene is not perfectly calm. There are droughts, floods, volcanic eruptions, storms, cold pulses, warm phases, and regional crises. But compared with the violent swings of the late Ice Age, many regions experience a climate more predictable across generations. That predictability matters enormously. Plants can be managed with greater confidence. Villages can return to the same rhythms year after year. Seasonal calendars become more dependable. A world that had lurched between ice, thaw, and sudden cold now offers enough regularity for human experiments to deepen. In Southwest Asia, this new climate helps create the conditions in which farming becomes more established. Wild plant management turns gradually into cultivation, and cultivation into domestication. Wheat, barley, lentils, peas, goats, sheep, pigs, and cattle enter human life in new ways over centuries and millennia. The process is uneven, local, and debated in its details, but the direction is unmistakable. People are no longer only adapting to the world as it changes. They are beginning to build worlds of their own inside it. The consequences spread slowly, then with gathering force. Villages grow larger, houses multiply, fields expand, herds become wealth, storage becomes central. Exchange networks move stone, shells, obsidian, food, ornaments, and ideas across long distances. Ritual spaces change. Social roles become more specialized. Some people spend more time farming, others herding, crafting, building, healing, trading, leading ceremonies, or organizing labor. None of this yet resembles the later civilizations of Mesopotamia, Egypt, the Indus, China, Mesoamerica, or the Andes. But the foundations are forming in the quiet pressure of daily repetition. The Holocene world also closes many Ice Age possibilities. Land bridges disappear. Britain becomes fully separated from the continent. Beringia is drowned. Sunderland breaks into islands. Coastal plains vanish beneath the sea. The great herds and giants of many regions are gone or reduced. People can no longer move through certain old corridors without boats. The map becomes more familiar to modern eyes. But for those living through the transition, this familiarity is built on loss. The world that made later history possible is also a world made by erasure. In many places, forests reach their greatest early Holocene extent. The expansion of woodland changes hunting, travel, and settlement. In Europe, Mesolithic communities develop rich forest, river, lake, and coastal lifeways using microliths, axes, canoes, fish traps, nets, and broad diets. They are not failed farmers waiting for agriculture to arrive. They are successful people living in post-Ice Age environments with deep knowledge and complex traditions. In some regions, farming later spreads into their worlds through migration, exchange, adoption, resistance, and mixture. The arrival of agriculture is not simply the replacement of one life by another. It is a long and often complicated encounter. Elsewhere, different Holocene worlds emerge. In parts of Africa, changing monsoons bring greener conditions to regions that are now desert. Lakes expand. Grasslands support animals and people. Rock art later preserves cattle, wildlife, swimmers, and human figures in places that today seem impossibly dry. The Sahara is not timeless sand. It has been green, inhabited, and transformed. In East Asia, rice and millet traditions develop along different ecological paths. In the Americas, after the disappearance of many megafauna, people adapt to diverse landscapes and later domesticate plants in several regions. In New Guinea, highland cultivation develops in its own distinctive way. The Holocene does not produce one human destiny. It produces many experiments. Still, a shared pattern appears. Humans become more numerous and more deeply entangled with the environments they shape. Fire clears land. Fields favor certain plants. Herds alter vegetation. Settlements concentrate waste and nutrients. Trade spreads materials beyond their source. People begin moving, not only through ecosystems, but as forces within them. This does not make humans separate from nature. It shows how fully inside nature they are, and how powerful a social animal can become when memory, tools, cooperation, and reproduction align. The warmer world also changes time horizons. A mobile group may think in seasonal rounds, though with memories reaching far deeper. A farming village must think in sowing cycles, harvest cycles, storage cycles, inheritance, house repair, herd growth, and land rights. People begin living inside investments that outlast a single season. A field cleared by one generation may feed the next. A house rebuilt on old foundations may preserve family claims. A herd may carry wealth forward. A burial beneath the floor may make ancestry part of property, identity, and power. The future becomes something to manage, not only endure. With this comes a new kind of fragility. A village can grow beyond what local wild resources alone could support. That makes it more productive, but also more exposed. A drought can threaten crops.
A disease can move through dense settlement. A conflict can destroy stores. A flood can ruin fields. Dependence creates strength and weakness together. Later civilizations will inherit this bargain on a larger scale. Irrigation will feed cities and create disputes over water. Grain will support states and taxation. Herds will build wealth and spread disease. Roads will connect people and carry armies. Writing will preserve memory and strengthen bureaucracy. All of this lies far ahead, but the first terms of the bargain are set in the early Holocene. The end of the Ice Age also changes human imagination of permanence. In the Pleistocene, people lived with immense change, but not necessarily with permanent architecture or fixed fields in most regions. In the Holocene, many communities increasingly build as if places will last. Houses, shrines, graves, terraces, fields and paths begin to accumulate. Yet the lesson of the thaw remains underneath. Permanence is always negotiated with climate, water, soil, and time. The people who build the first villages do so on a planet that has recently drowned coastlines and erased entire animal worlds. The memory of instability may fade, but the instability itself never fully leaves. Scholars still debate how directly the end of the Ice Age caused the rise of agriculture and demand civilization. It would be too simple to say that warming made farming inevitable. Humans had lived through warm periods before, without producing the same global pattern.
It would also be too simple to say that farming was purely a cultural choice, independent of climate. The Holocene offered a window: warmer conditions, longer growing seasons, more predictable resources in some regions, and landscapes where human management could become increasingly effective. People stepped through that window for different reasons, in different places, sometimes eagerly, sometimes gradually, sometimes perhaps because alternatives narrowed. What survives in the record suggests that the Holocene world emerges from both opportunity and pressure. There is more plant growth in many regions, but also more territoriality, more food, but more labor, more settlement, but more disease, more cooperation, but more hierarchy,
more memory fixed in place, but more land lost beneath the sea. The old Ice Age did not simply end and hand humanity a better world. It handed humanity a different world, and humans filled it with new risks. By now, the Great Thaw has reshaped almost every foundation of life. The ice sheets that once dominated continents are retreating remnants. The sea has reclaimed lands and hidden old human worlds. Many giants are gone. Forests, wetlands, and new grasslands have spread. People have learned new foods, new tools, new forms of gathering, and new relationships with plants and animals. In some places, they have begun to settle deeply enough that the ground itself records their return. The Holocene is not the end of the story.
It is the beginning of the stage on which the rest of familiar history will be built. Somewhere in the early Holocene, a village wakes to a warmer morning than its ancestors of the deep Ice Age would have known. Smoke rises from houses. Seeds are sorted. Dogs move through the settlement. Someone walks to a field or a stand of plants that has become almost a field. Someone else heads toward the river with a net. Children play above older floors, older hearths, older bones. Beyond the settlement, the world is still wild, still dangerous, still filled with animals, storms, hunger, and uncertainty. But something has changed that cannot easily be undone. Human life has begun to root itself into the new climate, and those roots will eventually crack stone. The thaw is still with us.
It is hidden in the shape of coastlines, in drowned river valleys, in the animals that are missing, in the crops that feed billions, in the villages that became cities, and in the uneasy fact that the world humans call normal is only the latest arrangement of a restless planet. 12,000 years ago, the Ice Age did not simply end behind humanity like a closed door. It became the foundation beneath everything that followed. The fields, ports, borders, myths, languages,
and civilizations of later history all stand on ground reshaped by melting ice. The traces are everywhere, though they often pass unnoticed. The North Sea covers land where people once walked. The English Channel marks a separation that did not always exist. The Bering Strait covers a region that once connected continents. The islands of Southeast Asia preserve the broken edges of a drowned tropical world. In deserts, ancient lake beds remember wetter climates. In forests, pollen records preserve the advance of trees over open ground. In caves and sediments, bones of vanished animals lie beside the tools of people who knew them alive. The modern map is not timeless. It is a survivor's map. Human bodies carry echoes too. Ancient DNA reveals movements, mixtures, bottlenecks, and replacements that followed the thaw's shifting opportunities and pressures. Some populations expanded into newly habitable lands. Others were absorbed, displaced, or disappeared from the visible record. Farming peoples later spread into regions occupied by hunter-gatherers, sometimes mixing with them, sometimes replacing them, often creating complicated human landscapes that simple origin stories cannot contain. What survives in the record suggests continuity and rupture together. No people emerge from the end of the Ice Age unchanged. The legacy also survives in food. Wheat, barley, rice, millet, maize, potatoes, beans, squash, and other crops do not all come from the same moment. But the Holocene climate makes their domestication and expansion possible in ways the unstable late Ice Age had not. Every loaf of bread, every bowl of rice, every field of grain belongs to a chain of choices that began when people started pulling certain plants closer to human life. That chain is brilliant and dangerous. It feeds cities, but it also binds societies to weather, soil, water, labor, and storage. The seed remains one of humanity's greatest bargains with uncertainty. The vanished megafauna leave a different kind of legacy: absence. Modern landscapes are quieter and smaller than many Pleistocene landscapes were. In much of the world, the largest animals are gone, and ecosystems function without the giants that once shaped them. Forests, grasslands, and nutrient cycles changed after their disappearance. Human imagination changed too. Mammoths and ground sloths became fossils, museum skeletons, cave images, and scientific puzzles instead of living presences. Scholars still debate the exact balance of climate and human pressure, but the result is beyond debate. The Holocene begins with a planet already diminished. The drowned coasts leave perhaps the most haunting legacy because they remind us how much is missing. Archaeology is not a complete book with torn pages. It is more like a shoreline after a storm, scattered with fragments from a world mostly carried away. Some of the most important human adaptations may have happened in places now submerged. Coastal migration routes, fishing camps, shell middens, ritual places, burials, wooden structures, boats, and early experiments in staying near rich aquatic environments may lie beneath sediment and sea. The evidence remains incomplete, not because people were absent, but because water is an efficient thief. And yet, from incomplete evidence, a powerful picture emerges. Around 12,000 years ago, humans endured a transformation that was planetary in scale and intimate in consequence. They watched animals shift and vanish. They retreated from coasts. They entered forests. They learned wetlands. They gathered seeds. They stored food. They built more permanent places. They gathered at ritual centers. They took on new risks of crowding, disease, labor, and inequality. They did not experience this as one grand turning point. They experienced it as weather, hunger, memory, opportunity, and loss. This is why the end of the Ice Age still matters. It is not ancient background. It is the beginning of the world system that makes civilization possible. The Holocene provided enough climatic stability for agriculture to spread, for populations to grow, for settlements to thicken, and for human societies to become increasingly powerful. But that power is born from vulnerability. Humans became strong by tying themselves to crops, herds, water systems, stored food, and fixed places. Every later civilization inherits that tension. The same settled life that produces temples and writing also produces famine, epidemic, hierarchy, and collapse. There is a quiet warning in this. The people of the late Ice Age did not cause the great thaw in the way modern humans are changing climate now. They lived inside a natural transition driven by planetary forces.
But their story shows how deeply climate can alter everything that seems permanent. Coastlines, food systems, animal communities, migration routes, social structures, and belief. It shows that human history is never separate from Earth history. A change in temperature can become a change in diet. A change in sea level can become a change in memory. A change in rainfall can become a change in power. 12,000 years ago, the Ice Age finally ended, but endings in deep time are never clean. The cold withdrew into mountains, poles, and memory. The sea rose over old plains. The forests closed across open ground. The giants vanished into bone and story. Humans survived as they had survived so much before, not by remaining the same, but by changing again. From that change came farming, villages, monuments, trade, inequality, disease, cities, and history, as most people recognize it. The mystery is not simply what happened when the ice melted. The mystery is how much of ourselves began there, in the unstable borderland between a frozen planet and the warmer world we inherited. The final window opens with that image of a shoreline at dusk, somewhere in the early Holocene, where the water has already taken the old ground, but has not yet finished rising. Behind the shore, smoke lifts from a small settlement. Beyond it, trees darken in the evening air. The people there know nothing of epochs. They do not know they are living after the Pleistocene or at the beginning of the Holocene. They know the pull of hunger, the weight of tools, the warmth of fire, the danger of weather, and the names of places that may not last. Over many generations, their world settles into new forms. The ice becomes distant. The stories of cold plains and giant animals grow older. Children learn forests instead of mammoth steppe, fields instead of wild stands, villages instead of wandering routes across drowned lands. What was once shocking becomes ordinary. What was once remembered becomes myth. What was once visible sinks below water, soil, and time. Yet the earth keeps the marks. A seabed holds a river channel. A cave wall holds an animal no living eye has seen for thousands of years. A seed carries the legacy of ancient hands. A human genome carries journeys made across vanished lands. A city rises on a climate gift that began with melting ice. The end of the Ice Age was not the end of hardship, nor the beginning of simple progress. It was a passage from one kind of uncertainty into another. It gave humanity a warmer world, but not a safer one. It gave stability, but only enough for new ambitions to grow. It gave abundance, but also dependence. It gave places to build, and then reminded every generation after that, no place is permanent forever. And if there is a final image to hold, it is not a glacier collapsing or a mammoth fading into snow. It is a small human footprint pressed into damp ground near a changing shore. The tide has not reached it yet. The person who made it has moved on, carrying food, memory, and fear into the evening. Soon the water will smooth the mark away, but for a moment before it disappears, it holds the whole story. A world ending, another beginning, and humanity walking between them.